Yeah. All right. Well, hello, everybody. Good evening. Tonight is March the 9th, 2021. This is the Dallas Personal Robotics Group Builders Night Virtual. My name is Carl Ott. I'm the current president of the club, and we're just going to do the usual thing we do each week and go around the table, see what people have been working on, what they have to show off, any questions. We'll try and stump the club and produce magic answers from our robot hats to solve each other's problems. So with that in mind, let's just start off. I think Ray and Jean have some, no, Pat and Jean have some simple updates. So let's get started with you guys, and then we'll figure out who goes from there. So Pat, what you got?
Basically, I've been waiting. I had some motors on order for my robot, trying to quiet it down. I ordered a couple motors from Palulu, and they've showed up. But now I'm waiting on a couple timing pulleys and some bearings from China, out of AliExpress. So when that all comes together, I'll revamp the drive gear on it and tie in the new motors and encoders and see how that goes. So I've been doing a little bit of work in the background, trying to communicate between Python programs. And what I've been playing with is MQQT. So I got a broker on the Raspberry Pi and basically created the bash launch file. And I launch all my processes as a separate process in Python. And trying to distribute the load across the CPU. So I'm using all the cores on the Raspberry Pi, and that seems to be working good. I've been tracking the update time with MQQT and MQTT, and what I'm finding is if I ask for a 20 hertz update time, for the most part, I'm there. So I'm at 49 to 51 milliseconds. I'm receiving a response. All of my low-level stuff is being handled by the Arduino as far as critical timing and calculating speeds. So I don't think it's going to be that big of an issue if the Raspberry Pi is a couple of milliseconds off. So that's about it for me.
So
Pat,
from where to where is the MQTT stuff happening?
It's on the Pi. So it's happening as on board the Pi as a local, the Raspberry Pi.
Okay. Just on board, because that was, so not across the internet.
No, definitely not. I don't need to add that latency into there.
That's why I was surprised. The numbers sounded pretty good, and then
Yeah, so there is a little bit of inconsistencies, and I don't know if that's between the processes on the Pi. So I'm tracking. Basically, I've got a launch file that launches all my processes. I've got the MQQT server running in the background, and basically I'm only communicating right now with one process, which is my motor control file. And so every time I get a response, I send back the time in milliseconds from that program to see what's going on.
Yeah.
And I'm seeing a difference of, like I say, 2 to 3 milliseconds.
Yeah, if you care about milliseconds, you really need to control priorities. And if you care about anything smaller than milliseconds, you gotta run real-time Linux. That's kind of the short advice. But even if you care about milliseconds and don't want occasional things that are way off, at the minimum, you gotta explicitly control priorities, and that might give you better results. But still no 100% guarantee.
Yeah. So when I've been watching it and logging it, I've seen one point where I was at 4 seconds on a response.
What?
And that one, I was amazed, and it's only happened once. And everything else is coming out 49 to 51 milliseconds.
Yeah, and that's, you're getting pretty lucky, because if you don't have much going on in the background, that's what you'll get. But by default, Linux tries to be very fair with how it's scheduling, and if everything's running it under the completely fair policy, again, it's doing well most of the time. But if you want better than that, keyword for you to look at is the CHRT command. You can launch your Python apps using the chrt command, where you can explicitly control the priority. And I'm not talking about nice values. I'm talking about putting your program into a different scheduling policy. So it's an entirely different ball game. And then you can, between policy and then the level of priority within the policy, you can control, how important, you can control the priority pretty well relative to everything else that's going on.
Okay. For now, I thought I'd just leave it as it is and see how much that few milliseconds affects the process. If I can stick away from the 4 seconds, so if I was at 4 seconds, my robot would drop out the motor drive. It would say, hey, I've got a response after 100, I think it's 100 milliseconds, and it would say stop. So it would lock itself out. And does that just as part of a safety. If I don't receive a message after 100 milliseconds, stop the robot.
Yeah, this is kind of in line with what the discussion that Chris and I have been having over me with the Raspberry Pi as well. Is that I've been trying to avoid having a custom kernel just because I don't want to have to build kernels. It'd be nice to just be able to create a new SD card and not have to build it. But I'm kind of seeing the same thing, that anywhere from about 49.9 up to about 50.1, 51 milliseconds per loop, and then every once in a while you'll see a blip. But for the most part, if the Pi's not overly loaded, it seems to be, I think you're right, Pat, it's generally pretty good.
Yeah, so for ease's sake of doing it, I did integer math and I just rounded it to the millisecond. So if it's 49.5, I don't really care. All I know is it's 49. If it's 51, it just lets me know that there is a little bit of variability in there. And for now, I want to see if the robot can deal with that as I go forward with it. Is it going to become detrimental to a routine? Trying to do all the low-level stuff, as I said, on an Arduino, where I can clock the time and be fairly accurate down to microseconds, or quite accurate with those. And so I'll see how that goes.
Well, one of the things that David Anderson had suggested to me was trying to use one of the Pi's hardware clocks, and I think I've posted something to the mailing list to that effect, that of the 4 hardware clocks, 2 of them are available, and I've got, if you can't figure it out, ping me in the mailing list and I'll go ahead and repost it or post what I've got. But I'm using one of the hardware clocks, and it's basically, as far as I can tell, impervious to the load that's on the Pi. That once you set it up for a 20 hertz loop, it basically sends back that 20 hertz pulse, irregardless of how hard the Pi is being hit. Now, the loop that calls that may be getting whacked, but the timer itself, I think, is basically pretty steady.
Okay. So I sort of figure that, if I know a meeting is coming up and it's in 5 minutes, I'm pretty good at judging when the 5 minutes is without having a clock. So if I can judge when 5 minutes is without a clock, I'm sure a robot can do something being a few milliseconds out, as long as you take that few milliseconds into the calculation. Yeah. So if I'm calculating a speed, a velocity, and instead of calculating at 50 milliseconds exactly, I'm 49.2 or whatever, then as long as I take that 49.2 into account, I can still calculate a velocity accurately.
And what time would you say it is right now?
It is 8:49 here.
Oh,
so that's 7:49 where you are.
That's pretty good.
Not bad. That's just off the top of my head. No, well, humans are really good at reaching out and grabbing something, even without looking.
Yep.
And, so, well, hey, can a robot deal with being a millisecond out? Let's see.
Yeah.
Yeah, I think that was news view on this, is that, we're probably overthinking this one, that maybe just a few milliseconds on a loop is not a big deal. And frankly, the accuracy that I'm getting is, as far as I can tell, fine for what I'm doing as well.
Yeah, so I'm looking at it, and let's say I'm calculating a velocity. Well, I may want to know that I had 130 ticks in 49 milliseconds or 49.5 milliseconds, but I can calculate a velocity pretty accurately with that value, even if it's not exactly 50.
Yeah, but if you think about it in other ways, this is something that David said, I think, was that if you are recalculating the behavior of the robot every 20 milliseconds,
Yeah.
I mean, every 50 milliseconds, if you're saying to the robot, what are you going to do for the next 50 milliseconds? If one of those 50 milliseconds says turn left, and then 50 milliseconds later it says don't bother, then it's not going to do anything.
Yeah.
Will average out.
And the idea is that once you determine a behavior, is it a servo behavior or a ballistic behavior, and you're going to let it run for a little while anyway. One will run through, a ballistic behavior will run through its complete cycle, barring detrimental death to the robot, I guess. And whereas a servo behavior will take everything into account as it goes.
Yep. Sounds like you're having fun.
Oh,
Yeah.
that and too much work. So
I did have one question. You said you sent off to China for some of the parts. Has anybody had any experience with Servo City, or there's another company? They basically sell all the servos, hardware, little mounting brackets, all that kind of stuff. Has anybody used those guys?
Doug, I thought you were a fan. No?
I've ordered several things from them and always had good luck.
Yeah.
Yeah.
the shipping is the problem to Canada. They've got good prices and all sorts of stuff, but as soon as you're crossing a border with shipping, you're doubling the cost of an order.
Yeah, because it's Acto. I've just looked it up. It's Actobotics and Servo City. They seem to be kind of maybe the same company or something, and they've got enormous like bearings, mechanical parts, lots of moving parts, racks, everything you can imagine at a sized for robots. And I'm kind of just starting to dream about maybe a rocker bogey robot with the steering and everything, and that gets into big money, but it's also just about impossible to do here in New Zealand with the parts I can get here. And that was one of the suppliers of all those complicated parts. So, but Ted, you said you've had luck with Servo City?
Right. I've ordered some of those parts, the bearings and some of the linkages, and let's see what else, some sensors. I think some of the Actobotic sensors. And I've placed, I don't know, 3 or 4 orders. Not in the last, it's been a couple of years probably, but.
Cool. Thank you.
Yep.
I've placed about 10 orders with them, and I can say that they're good, solid company, very high quality parts, decent pricing. It used to be really discount pricing for servos, but it's just decent pricing now. But they're used very extensively by the FTC and the FRC robotics competition communities. It's a good supplier. Highly recommend them.
All right, thanks very much. It's good to know.
Cool. All right. So, Jean, I think you had kind of a brief update you mentioned.
Yeah. So on the robotic side, not too much, but I've been reading. I mean, I mainly work with C++ nowadays, and I've been reading these some guidelines, and it turns out there's so much for C++. I guess like different constructors. Anyway, so that's where I spend a lot of time and realize I know so little about C++. On the other side, so I'm still trying to struggle with this using this prototype board to connect my what do you call this Wixel board. It's really strange. I want to use this because I want to have a stable connection, but just so few wires, and it's already like sometimes connects, sometimes doesn't. So I'm changing to this, and I don't know if you guys think. I thought having a header on here is a good idea, where I don't have to solder my Wixel to a board. But now I'm hesitant whether adding a header will cause problem. I don't think it will, but
Shouldn't. Yeah.
Oh, okay.
You're not dealing with 100 megahertz signals here.
Okay, yeah, then I mean, Yeah, it's weird. It's just like a few wires on here, and it's already not working. So I was using my oscilloscope, looking at the signal. Sometimes it has the signal, sometimes it doesn't, and I don't know why. So, but yeah, I'm gonna switch to this type of board, almost exactly like the breadboard, and yeah, so that's hopefully I have better luck on this one.
Well, John, we've talked about this before on the forums, and like I've made dozens and dozens and dozens of these little header things, usually for I²C, and they're 4-wire things, and I solder them, and they're tedious to make, but I've got to show you. For example, this is my KD01 robot. I don't know if you can see that, but there's just headers all over this thing, and they're all handmade, and I have yet to notice one of them not connecting. They seem to be pretty reliable. I'm just using the standard, I'm not sure what these things, I think we're calling them DuPont connectors, and I literally have never noticed a problem with any wiring once they're plugged in. So
Maybe you have a floating input, something that's supposed to be pulled up or pulled down. I don't know the VXLANs, so I'm not sure if that's applicable, but something to look at.
When I first got it, I put it on a breadboard, like poking these wires in, and it worked. So I thought, wow, it's straightforward. And then took me a while to solder this, but I think these points are too flimsy. I'm trying to, it's like one point. I'm trying to solder a wire on top of that one point. So I'm thinking with this, I have these solid connections inside. So yeah, I have like one wire per hole here. So I think it's safer. Where over here, I have this one connection soldered, and then I try to dip my wire on top of that solder. I think that's where the problem happens.
Yeah, on a sea of points like that, I never use that type of prototype board. I mean, they're hell on earth. So yeah, I mean, if you're going to use a proto board, the type you held up, which essentially is made for ICs and for headers, which are for ICs, it should be simple as heck. I mean, I know that when I made mine, it's 2 resistors, or might even be 1 resistor, 2 resistors, and that's it. And I think you probably just, like I say, that's sea of points is just, I think that's probably giving you more headache than you want. So yeah. And now you're going to be glad you used the header. Because pop your whistle off, take the old board and chunk and start over again. See what I'm saying? Just throw it away and get a new one.
This one's worked. I've actually used wire wrap wire on these. I've got a ton of it and all the hand tools and one wrapper that you actually plug into 110 volts, and you can go to town wrapping wires till your heart's content. But they've worked okay. You sure your soldering iron's hot enough and you're getting good solder joints?
I mean, it could be a cold joint, right?
Yeah, it's possible.
It sounds like it comes down to the soldering skills. Like there's a guy I worked with at TI. He would solder to solder. He was so proud of showing off his skills. He would take two loose pieces of solder and he would join them with a soldering iron, and a pretty neat joint too. So
yeah,
that's where your ohm meter is your friend, and you can check all that out, and you can check it out. Just take your Wixel out of the board, and then figure out, okay, if I was at this pin and I was at this edge of the resistor, what would I read? I'd read the resistor, right? Well, do I read the resistor? If I go to the other end of the second resistor, do I see the total resistance of the two? You can just logic it out real quick.
There's another alternative, which is that if, I'm sure that we all know that robots are never finished, and I am constantly making changes in mine. So there's parts of my robot where I just take the little solderless breadboards and put Velcro on the back and just attach it to the robot with Velcro. And so anything that's not going to be permanent, I just solderless breadboard it. And it's like all the IMU stuff that I'm doing and all the experiments I'm doing on solderless breadboards. So if you've got enough room on your robot, don't solder anything, just use solderless.
I will tell you, my hint on that sort of breadboard is just a couple things. Know that they've got a bandwidth limitation. So if you're doing some high bandwidth stuff or high frequency stuff, you're going to have a problem there. And two, spend a little extra money on your breadboards, because there are better ones than worst ones. And the worst ones, all they're going to do is cause you problems.
Amen.
Yeah.
And the same is true of those header pins too, because as it turns out that if you look inside the header pin, they're just like folded metal with little spring contacts.
Yeah.
And what I found on, I had a bad batch of header pins, and unfortunately I soldered it, and it's now very deep in my one robot. And that header socket, if I can put like the round stuff, like some of the DuPont pins are round, some are square, and some are rectangular in cross section. And I've noticed that the header pin that I put in that was in the Mega it expects a certain kind of like a square post, and so that the header that I put in the motor shield that plugs into the Mega, it has a kind of rectangular cross section post, and it makes crappy contact with the header pin in the Mega. So I have to juggle the board just right and then hope that I don't bump it too much or it loses contact. So the headers, connectorizing is good, but you want to make sure you use good quality parts that are reliable for mechanical vibrations.
Yeah, I don't know how many insertions the DuPont header pins are good for. Maybe 10.
That's another thing too, right? Some of them are more than others. And plating, right? So
yeah, that's like when I'll show later on was when I'm putting on my IMU together, and I take a magnet and I check each DuPont, because depending on where I got that DuPont pin lead, some of them use steel and some of them don't. The ones that use steel, you probably don't want to have on your IMU. But I'm just saying is there's a tremendous range of quality variation in some of these inexpensive components.
But I'll tell you guys, that's where I've come to the conclusion that if it's going to be something that you intend to plug in once and leave it be in the robot, DuPont, fine, you can get away with it. But if it's something you're going to unplug and replug and unplug and replug, just like Ray was saying, just go to Amazon or wherever and get a bunch of these ready-made. These connectors are meant for multiple putting together and taking apart and putting together. They're meant for it. So just get these, solder them in on the other end, and then you won't have to worry. You can unplug it, which is good. Take your robot apart, plug it back together, and you don't have to worry because you're not going to wear out the contacts.
Yeah.
How about the difference between a JST and like a DuPont?
Oh yeah.
So you can get the 0.1 inch JST connectors.
Yeah, that's what's now really becoming popular with Adafruit. They're re-releasing almost all their boards with they're called STEMMA QTs, the little tiny ones.
Yeah, those aren't separated by, a tenth of an inch though. It's less.
No, much less. Yeah, they're tiny.
Yeah, but I know you can get the JST. I forget what series. It's the XT series or something, and it's 0.1 inch.
Yeah.
Oh, okay. Yep.
The problem with those,
if you
the
start out
biggest
with a round
problem,
pin, you better stick with a round pin, and I think you can go forwards, but you can't go backwards. From a round pin to a square pin. But if you started out with square pins and you go to a round pin, you're asking for trouble.
yeah, Pat, the problem I've had with those type of connectors is they're kind of unfriendly for you making your custom length ones. Now you can buy, if you go to eBay or Amazon, you can buy, like a pack of 10 with, they'll be 18 inches and you can cut them up to be what you want. But I still, if I'm doing something because of the ease of doing it, I still prefer the 0.1 or the 100 mil spacing. But those other ones make very good secure socket if you're using a board that's already been designed. You know, like a lot of my cameras use those.
Because you can buy them as well that you can crimp the ends on and then put them together.
Yeah, you can. What I'm saying is, if you think putting a DuPont connector is kind of hard to do, you're gonna with a is it JSH or JSP? It's a
JSP.
Japanese standard, whatever. Anyway, those are really tough to hand crimp.
I will plus one you on that one on those things. I've got a whole bucket for them and a crimper thing, and when I got to crimp up connections, I basically clear my schedule for the next however. Tell the wife that you're about to hear lots of profanity, and just get ready for it because it's coming.
Yeah.
Well, there you go.
I'm
That's a very clear idea of what to expect.
Yeah, I would say on that, if one of the things you sometimes get away with is, like I say, you can get the one end pre-made, and they usually come with either male or female. And then you, on the other end, you can use the standard DuPont females. I again would stress that whatever you want to do, you don't want to use a DuPont male connector. Okay, I mean, everybody does, but I'm going to tell you that there's the strength in putting it on one of the header pins, you know, a header, yeah, like that.
Yeah.
It's very, very, very sturdy. But if you're putting one of those little crazy male DuPont pins, it's so you bend it a little bit, whoop, it breaks.
Yeah.
You know?
I
So
agree.
that-
I
that's- I
got
was
a whole
on-
bunch of those. Go ahead, Pat.
I've been on the fence about buying a kit for DuPont or JST. And I just like the way the JST go in. They hold in nicely. They're a good connection, but I've never made any. You know, the boards you get. So I was always questioning whether it would work. The DuPont I've done before, and they're pretty good.
Yeah, they're pretty.
I
I mean, once you gain, you know, once you learn how to hold your tongue while you're doing it, you can be pretty successful. But you still screw one and two. You know, it's like was mentioned earlier. You know, you always have to take a little more time than you think you're going to take. Oh, I just got to put 4 of them on. Well, actually, you probably use 6 because you'll screw 2 of them up, and that's just the way it is. You might get lucky, but you go down to those little itty bitty ones, and you know they come in series, as you know. Try to stay on the large end of the series, you know, the large spacing series.
Yeah, well, I'm looking at the 0.1 inch series, the standard breadboard.
I thought they were all metric. I don't think there's any 0.1.
I thought they were all 0.1, 2.54 millimeters.
Oh,
Really? Oh, I thought
I
they were.
would say that I would have thought they're, you know, they're smaller typically.
The JST ones are,
Yeah.
but the
Yeah.
DuPont are 0.1 inch or
Oh, yeah.
2.54 millimeters.
Yeah. And the JST ones, as Doug said, the J is for Japanese, I think. So yeah, they're
Yeah.
metric.
Japanese standard. I don't know what the T is.
Yeah. And I just to confirm what Doug
Maybe.
said, I've got 2 boxes of the DuPonts, and I've gone through, like I said, making many cables, and every single time I've used the male ones, yeah, they're just too flimsy. So that's why I end up with these kind of double long males that I put on the board, and then just avoid using the male DuPonts, because the little post on the end is just you know, very thin metal, and it'll snap almost immediately.
Okay.
Yeah.
Yeah, I think the least 2 reliable components in any circuit are connectors and switches. So the more you have, the less reliable the whole thing.
Yeah. You know, in a perfect world, you know, you would actually design your own circuit board, and you'd have all of your wires come off your circuit board through JST connectors, and everything would be really great. But for hobbyists, that's a hard dream to achieve. Yeah. Hey, I got something I want to say if you, or show. You got, can I show something?
What you got? Go for it, Doug.
Okay, let me, let's see here.
And I got something after you.
Okay. Okay. And let me see, I think it's here. Okay, and somehow you're supposed to.
Woohoo.
Yeah, I wanted to say, I, this is my, test. It's actually a test robot. I was really trying to play with this wheel support on the other side. That's the reason why it drove me to start this robot, which is kind of an odd reason. But it also gives me a chance to do my yearly update of my software, you know, where I try to take the skills that the C skills that I've learned and try to improve my code, come up with better variable names, stuff like that. Yeah. And anyway, as you can see here, it's a basic, inexpensive robot underneath using a mega board. And here is my setup that I have. I've created libraries for to control communication with inside of the robot. And this is my BNO 055 right here, which by the way, I just saw that the price of that is $18 now. So they've halved it. So here's another view of it. Whoops, not that view. Wait a minute, I went the wrong way. All right, here's look.
It's gotten with a magnetometer.
Anyway,
Was
here's
that Adafruit where the BNO was 18?
yeah.
Okay.
Then they've actually got a version 2, and what they've done is they've added some of those. I don't know what the name of the connector is. Very similar to a JST, but it's not JST. I think it's some other
Stemma
proprietary.
QT.
Yeah, and you
Yeah.
can stick those,
Quick, I guess.
but you don't have to. If you look at the board, it's the same old board with those added on. So you still have access to if you want to use DuPont type connections. Anyway, so this is I would love, you know, this is a project here that's going to drive me to make another board. This works really nice, this idea of having these 6 buttons here. But I would prefer to have a 4x20 instead of a 2x20, or I think this might be a 2x16. Would be a nicer display. So I don't know, that might force me to see if I can replicate this with, or maybe not even use an LCD screen, maybe go to one of the, what is the OLED? Now, here's just a view from another angle. Here's what it looks like underneath. So these are the DF Robot TT motors from China that have the encoders on the end. And this is a really nice wheel that comes from DF Robot that David Ashley actually turned me on to, and we did a joint buy on that. It's being powered by 3 18650. Yeah. Now the motors are only rated up to like 7.5 or something like that, but I haven't had any issues. But then again, I try not to drive them at full speed, but they are going from 0 to 12 volts on the rail, you know. So, but I haven't seen anything get over hot or anything, so everything seems to be. And you can also get TT motors that are at 12 volts, so I'm not too concerned about it. So that was so that's pretty much the pictures that I wanted to show. So right now, like I say, I wanted to mention, you see the front here, there's a little knob. That is where, and if you were to look right, you can see this, I can't get it. There's a hole right below the arrow, below the cursor. There's another one over here, not an arrow, excuse me, a hole. And that's part of the support holes for a front deck that goes on. but I'm not going to, that's usually where I do my obstacle avoidance stuff, but I'm not going to do that on this one until I get my other software written up to do it. And I got big holes and it's a lot of spacing. Because like I say, I view this as a test robot, and it gives me a lot of way to get into the wiring fairly easy without having to tear it back down. And let's see, oh, and I have the on-off button on the top, and I have the start-stop button on the top. So everything's cool. And like I say, now it's just a matter of rewriting the software to make it more succinct. And you can see underneath here, you can see a part of my flow diagram for the logic. So anyway, that's pretty much all I've got to show, but I finally got this part done, and it should be able to be in its current. I'm gonna get this. Oh, stop sharing. To get out of excuse me, what I'm going to say right now, it's complete enough to essentially do navigation. Okay, obviously you wouldn't want to do navigation without having some sort of obstacle avoidance, but right now it's capable of doing navigation and being testing software. So that's what I'm doing, and when this gets done, then I'm going to be taking hopefully a lot of this over to my rover, because that's what I really want to do. Rover, August is really close, guys. I mean, it's really close. So,
yes, as Jesse would tell us, because Jesse's out to win it.
Yeah, I know. I don't know if you had heard, but Jesse actually said he wanted to compete with us. So here's the guy that's won Spark Fun for 2 or 3 years. The bar is going to be high, guys. So, luckily, and Kareem, one of the things that I should mention this, we are going to revise the rules slightly that will allow, I can't remember, RSK?
RTK.
RTK.
Oh, really?
GPSs will be allowed this year.
Ooh.
Okay. So
Are you going to allow high-speed collisions between robots?
no, the way they're staggered, that would really be unlikely to happen.
But we wouldn't want Jesse to tear up the. Yeah.
But yeah.
I think Jesse wants to do a Scott Gibson. He just wants to come down here and kick ass,
Yeah.
Probably so.
But that's okay. And I know some of you guys are not local, but you're welcome to come on down. If you've got a itch for a COVID relief road trip, this might be the thing to do. Just come on down and stay a couple of days. You might even be able to put up some of you guys if you so you won't have to pay your hotel bill. And
cheap
love to see
from
you.
New Zealand, maybe. I don't know.
I'm sure that
2022.
coming from New Zealand, that would be a big
It's only
wondering
19
about
or 20 hours.
We had somebody come from Vancouver one year. That's not too far.
Yeah.
And he did, and he hit a beautiful robot. So you can
He
look
nailed
at
it.
Yeah, you can look at, and he did it old school. You can see it on one of the Roborama videos from past years. He did a tabletop robot.
When in August is it?
Second week.
Yes, it's currently on the 14th of August, but I was going to lobby to try and change the date around because I had forgotten that's actually the date of my daughter's wedding. So
Okay, well, we can do, well, Carl, we can do that. I mean, we haven't posted anything. So,
her Our wedding was supposed to be last year, but then this funky virus came along. So
Yeah.
wedding part 1 was a cornfield in Iowa.
Yeah.
Wedding part 2 will be where it was supposed to be in Chicago.
Okay.
So,
Cool.
Sounding good.
Yeah. So anyway, yeah. So it sounds like second week won't be. We probably need to send I'm going to do the rules and I'll post them out to
Okay.
the officers, and then officers can give me a yay or nay, and then
Yep.
based on that, we'll actually put them up on the website. And we'll also, Carl, figure out a date that would,
I was going to propose the week after just to get us all a little extra time.
Is that good enough for you? Do you need next?
Yeah, that'll
week?
work for me.
Okay, all right.
Yeah.
So I'll put it down. I'll tentatively put it for the third week of.
Yeah, I think it's the 24th,
Okay.
21st, 21st.
All right.
And that also starts to stay away from Labor
Any
Day.
idea
So.
what the robot's expected to do?
Say what, Doug?
Sorry.
Any idea what the robot's expected to do generally?
Oh yeah. You can look at on the website. You can go to competitions, and then you can go to rules. And under the rules, you'll see all of the different contests, the rules. And under one of those is one called Robo Columbus. And it might be Robo Columbus Plus or something like that, but it's Robo Columbus. And you can see the rules. The rules will be 95% the same. We're just relaxing them so that an RTK GPS can be used.
Yeah. You used to have like an 18 by 18.
Yeah, but yeah, it's 18 by 18, so that shouldn't be. I don't think that, Kareem, that's your box that you usually build your robot is the 18 by 18 by 18, I think.
Is this for the outdoor robot?
Yeah.
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 Yeah,
Oh.
so my outdoor robot's definitely bigger than that.
Okay, send me a dimension and I'll
Okay.
set it in. Give yourself an inch or two on it. So don't go crazy though. And right now the current rate is 50 pounds.
It's lighter than that. It's just longer.
Okay.
So I'm talking about the one that's based on the 5th scale crawler.
Yeah, though we should be able to accommodate a 5th scale crawler. So so probably, but so that's another thing I'll look at. Send me if you can give a quick measurement. Let me know. Okay.
I can tell you right now, it's basically 3 feet long.
3 feet.
And it's rival, right?
I could.
So say 30. So would 36 by 20 be okay? Anybody have any issues with that? 36 by 20.
Can it extend beyond that?
You're gonna use your cart?
Well, okay. So let's say you had a telescoping pole to touch the cone. All right. I guess that would be a lot. I think we could write it so that it would have to fit in a 36 by 20 initially, and it could be
Starting frame?
Yeah, reconfigure.
And
That
if it
would work.
exceeds it, the judges will take a Sawzall to it and make it fit.
There you go.
It's happened
Yeah,
before.
I just cut the bottom of the wheels off so that the height is right. So,
Yeah, they'd only be flat on one side, so you're good to go, right?
So our
That's the
helium
truth.
What about
That's
how
the
you-
robot's robustness.
counteract weight,
okay. All right. Anybody else have anything else that they think that they might run into? Any size? The dead man switch is currently allowed to be either dead man or I forget what the name of the other mode is. Otherwise, one of them you release, the other one you have to push. Both are allowed. So that's already in the rules. We did that, I think, for David because he was getting tired of holding his button. So
I guess there's the dragging man switch,
Yeah,
Try to
well, that's the other option. You're also allowed to tie a tether to the robot. And in theory, the tether is not to tether the robot to you, but so that if he gets away from you, it's supposed to disconnect a switch. Okay. But I've never seen anybody use that option. Okay, well,
I've only used it on treadmills when I trip,
Yeah.
throw them back and
yeah, yeah.
comes in
Okay.
handy.
Okay, I think I'm going to jump in then. So I've got show and tell, and then more of a tell and show. So believe it or not, I'm still working towards the telepresence thing, but what I have at the moment was follow through on this, what I'm calling hover sim, and it's kind of like a test bed for various things. But what I finally managed to do was, I don't know why it took so long, but this is a B&O 055 right on here. And I finally closed the loop for heading. So it won't work if I click that button. I have to do it on my phone. So, so I have a routine here that lets me put it in maintain constant heading. And right now, east is pointing down, just by the way I have the video showing. So once I start the routine, display will go purple. So I set it off to some goofy angle, and now it, woohoo, it points itself east. So so now I can go and turn it around offset a little bit and press go on the routine again, and it'll turn itself east. Now it took the long way around because I have some math error I have to figure out, I guess. But pretty much no matter where you put it, it just wants to face east. So
Big question. Are you using the magnetometer?
I am not using the magnetometer. Well, and that's an interesting thing because as far as I can tell, all right, I put the B&O into IMU plus fusion mode. And I did that because it then apparently uses the compute resources on the chip to integrate gyro feedback. So in IMU plus mode, it I think what it does is it uses the magnetometer when it first boots up for an initial read, which by the way is remarkably close every time I've tried it. But then from that point on, it ignores the magnetometer and it only uses the accelerometer and the gyroscopes.
Oh.
And the thing I like about it is that it outputs 0 to 360 degrees. So but it's relative in IMU plus mode, it's relative to its starting position, whatever that happens to be. So I'm far from getting it all calibrated, but go ahead, question.
Oh, yeah. I just wanted to say that I was using one like that, a B&O 055, and I got it in the wrong mode, and it was, like you said, I think it was using the magnetometer to get a heading, and then it was trying to calibrate, and was doing a self-calibration that would take, well, if you didn't spin it around, it would take a couple minutes, and then it would come up with a new magnetometer heading, which was off by, several degrees from what it originally was. And it took me forever to figure out what was going on, because it would suddenly, the heading would change by several degrees. So just watch out for that.
Yeah, that's thank you. That's exactly what I was thinking based on all we've heard was, I mean, I don't care about absolute, for the way I'm thinking about it, I don't care about absolute orientation to the earth. I just care about like absolute, or I care about change in orientation over some period of time. And I'm totally happy if I can take a read when it powers on and then like notice, because there's, you can't see it very well at this angle, but you can read out some bits that tell you whether it's still considering itself calibrated or not in fusion mode. And it tells you whether the component detectors are calibrated, so the gyroscope and the accelerometer, or the fusion mode is calibrated. So right now, I think it has F3, G3, I mean F1, G3, and A3, which means the accelerometer and gyroscope are fully calibrated, and the fusion algorithm is also calibrated. So I was going to watch the calibration status and see how long it could hold it, just with moving it around, doing crazy things. And then if it seemed like it was going to lose it for very often, then I was going to figure out what else to do. But anyhow, it was cool to see it come together. And yeah, and so far, like I ran the calibration once when I was in Pittsburgh a month and a half ago, and I stored it in an EEPROM, and I haven't touched it since. And every time I turn it on, it comes up calibrated.
Wow.
So, and it stays calibrated for anyhow enough time to make a video.
Hey, Carl, are you on a Pi or an Arduino?
This is an Arduino Mega.
Hmm.
And again, this is just like an eval platform. So I'm learning about mecanum wheels, and I'm getting some software libraries figured out and on my own that I want to build off of. So this is all a low-level platform at the moment, which takes me to the next thing, which is this guy. And so we've been talking about the telepresence robot project for DPRG, where it has you know, normally most robots will probably have a low-level thing and then a high-level CPU. Well, on this one, this is a 2016 Club robot with an extra deck. So down below is the 2016 Club robot part with a lot of mods to it, Arduino Mega, and a motor shield that has really crappy header connectors. But and then the upper part is a Raspberry Pi. And then I have a custom that I wrote SPI interface between them. And I did it custom because the Pi is the master. So I don't use the Mega library for SPI. Instead, I have my own library that reads the SPI port. And anyhow, I had my reasons for doing that. But the bottom line was I had hoped to catch up with Chris, and in 2 hours, in a mere 2 hours, get my own little robot running with our part 1 example that several of us are trying to do by the 25th of this month. So this is the part 1, and they use this kind of robot. So I can successfully, this is the tail part. I made it down through about here, where I was able to basically get the Amazon Web Services platform pieces in place. So I have certificates in place. I have API endpoints defined. I got my account ready to go. All I need is a robot to connect it to. And wouldn't you know, I tried to turn on this robot that I hadn't turned on since last June, and the Pi wouldn't talk to the Mega. So I ran out of time. Later on, I figured out I had a loose ground wire in there, thanks to one of those, did I mention the header connector pin problem?
Yeah.
So once I fixed the, and that's where the oscilloscope probes are still in place, because once I found it's easy once I saw the missing ground connection, and then it started working. So now I have, now all I have to do is take this code, which knows how to talk to the Amazon Web Services platform, and I have to mash it up so that it can use my proprietary SPI interface to control the robot on the bottom. So my target, I'll put that out here tonight. That's my target for next Tuesday night. Saturday's blown because of the meeting, but maybe on Sunday, robot time will, maybe I'll be able to show you this with the Amazon Web Drive mechanism. That's my plan.
So Carl, that page you were showing between the robot, do you have the
Yeah.
address of that? Do you want to post that?
Yeah, just for those that don't already have it, this is the page to part 1 of the AWS telepresence project. That several of us trying to do. There you go.
Thank you. That way I can read up on it.
Yeah. That was pretty straightforward to do. Just stay with the roots, or with your root access on AWS. Don't try and make special fancy logins, and you'll be okay, I think.
the one thing that tripped me up, and I don't know if that was an issue for you, or it confused me a little bit in between, because AWS has these different zones, right? Different regions
Oh, yeah.
where the servers are. And, all my stuff that I usually do, I guess it's, somewhere in Virginia here on the East Coast. And I followed that part one of the tutorial and just, without really looking too closely, just followed it to the letter. And it created stuff in some other zone, like Oregon,
Yeah.
right? And the way the Amazon management console works, on the top right corner, you got to select what zone you want to be in, right? Because you select the zone, and then it's going to show you all the stuff you've got going on in that zone. And so I was confused. It's like, why am I not seeing the stuff that I just created? Well, then I realized, okay, well, I got to select another zone. Then I see that tutorial stuff, and if I want to see my virtual machines, I got to go back to another zone. So that's a little, I should redo it so that the stuff from the tutorial, I should have created it in my default
Yeah.
zone, which is Virginia.
Yeah, that's the joy. It's a pretty full-blown platform, that AWS. So there's a lot of knobs and switches to get lost in if you're not careful. I'm with you. I had some legacy projects in Virginia, and I decided that for this one I wanted to run closer, so I took Ohio. But now I know that depending on the viewpoint, I won't be able to see the other ones.
Yeah, the thing is, the pricing is different between the zones, right? So sometimes
really?
I take a look at, okay, what's the current pricing for compute time?
Huh.
It's not the same everywhere.
So you're saying you should hunt for zone sales, huh?
Oh, they have a thing where you can. I knew a guy that did this for his business. He did machine vision, and he had these fancy license plate recognizer things commercially that he offered. And for training it, you can burn a lot of GPU cycles to train CV models like that. So what he would do is he would take advantage of this Amazon concept where they basically they give you like 90% off. So you can get an Amazon GPU instance for 90% off.
Oh, the
And the only
spot,
downside,
what they call the spot instances?
yeah, the spot instance. And the only downside is that if a real paying customer comes along, there's no warning, you're going down. So he would queue up his projects, right? Because he knew when the GPUs were unloaded. So he would queue up his projects and use spot instances all night long and hardly ever get shut down. But I don't think for what we're talking about for a telepresence, it doesn't make sense. But if
yeah, I mean, you can set a threshold though. You can say, hey, I'm willing to pay up to this much money, right? So you won't get kicked out until the going rate goes even beyond that. So you can set it up so that you get the 90% off most of the time. If there's peak demand, you know what? Maybe you'll just get 50% off. Maybe you get only 20% off intermittently. And, so I have one running right now in that fashion. And I don't know what the real savings are in the end with the tiny machines, but yeah, you can set it up that way that you don't immediately get kicked out.
fun with the cloud. So what do you got, Chris? That was my update. Do you have some progress this week?
So on that front, just a small progress, nothing to demo, but what I've been, let me see, what I've been tinkering around with on the teleop side, trying to build up a little bit more. I should really do part 2 of that tutorial. I really want to see that in action on my robot too. But I've been more focusing on getting the Pololu control panel with the integrated video and expanding that a little bit. And the way it is right now, it's with the Python libraries and so on that I used. It's not really using a real web server, but what that prevents you from doing, for example, is if I wanted HTTPS with what I've shown previously, can't really do in a straightforward manner. So I wanted some authentication. It's not really set up for that. So what people do apparently is they take a real, quote unquote, real web server like Apache or Nginx, and put it on top of the Python stuff that runs the web application. That's often built in Flask in this framework. And so now in the real web server, it's just sort of passing stuff on, kind of interacting with the Python application through certain mechanisms. And now you have got a real web server, acting as kind of a front man. And now that opens up options there for doing HTTPS and for doing authentication. And so, so I played with that a little bit, and also with obtaining a certificate, which I had to do some of this stuff for work in the past. So I have a proper name now set up for my virtual machine and the certificate. And what that means, let me just share here. Last time I gave you guys sort of some random IP address, right, to go to pull up the web page. Why is it not letting me present? But what I've done is I have I don't know, some of you might be familiar with this dynamic DNS, and I have an account with dynedns.org, which I've had for a gazillion years now. Can you see my screen?
Yep. Nginx.
Yeah, so there's nothing much going on, but just sort of three little things going on here that I just wanted to highlight. So number one is, well, okay, so this is the real web server that I'm running, and it's not talking yet to my, this is not yet talking to my Pi. But Nginx is one popular real web server. And again, by putting that in front of the Python app, you get a lot of web-like features. So I wanted to show that. The other thing I wanted to show, see, I didn't go to an IP address. I went to romifromct.com. So I registered that name with dynamicdns.org. Again, dynamic DNS, for those of you who are not familiar with the concept, is people use it a lot with situations where you get a dynamic IP address from your ISP, right? And you don't want to pay for a static IP address. So you get this dynamic IP address, maybe it changes once a day, maybe once a week, maybe once a month, doesn't really matter. But you use this dynamic DNS service, and there are many, and you use sort of a little utility that's running on your computer, whether that's your PC at home or whether that's my Raspberry Pi. Either way, you're using a utility to sort of update sort of the IP address associated with a certain name, right? So I have this name registered, Romy from CT, and the IP address associated with that will change the moment I shut down my Amazon virtual machine and start it back up. Because every time I restart my Amazon virtual machine, I get a new IP address, right? But I have this little utility automatically running on the Amazon VM that'll talk to dynamicdns.org and tell it, hey, by the way, my real IP address is now X, okay? And so the moment I go to this will always have the latest and greatest IP address, and it's all set up so that your computer won't cache this address for more than 20 seconds, right? It's meant for a dynamic situation. Standard DNS, once you get the address associated with a name, the time to live associated with that name is fairly long. It's like on the order of hours or days. But with this service, right, when your computer asks, what's the IP address of this? It's going to get the IP address, and he's going to be told, this is only valid for the next 20 seconds. So you better ask again in 20 seconds if you want to know what the IP address is. Because that way, right, if the IP address keeps changing, it keeps staying up to date. So that's a key part of this dynamic DNS. which, you know, again, for the kind of thing I would be doing here with my Amazon VMs, you just kind of have to have a setup like that in place. So that's the other thing I wanted to show. I got a name. And number 3, so HTTPS, right? So again, that's what I get with Nginx. I have the ability to do secure HTTP. You know, next step would be, let's say, some sort of login, authentication. But the key here is, for those of you who are familiar with it, right? This is saying, okay, everything is fine and dandy here with this secure connection, nothing suspicious here. And what that means, of course, this is a real certificate, right? This is not some sort of self-signed certificate. So this is a real certificate I created with a service called let'sencrypt.org. It's pretty popular. I've used it in the past, but the gist of it is, right, you get a real certificate that your web browser will recognize as real, okay, and won't complain about, and you won't have to sort of do any hacks on your computer in order for your web browser to stop complaining, right? Which, you know, there's certain ways to generate these security certificates called self-signing. If you do that, your web browser would immediately complain and say, hey, there's something not right here. You know, do you really want to proceed? You know, you probably have seen that warning before. But with this service, which is pretty straightforward to use, you know, you're given a real certificate that you can install then on your web server. And so when you go to that website, you know, with the standard web browser, the web browser will be happy. It won't look suspicious. You won't have to acknowledge any kind of warnings. And yes, I want to proceed. Yes, I want to proceed. That sort of thing, right? So that's pretty key. Otherwise, it gets pretty annoying. So I played with that, put that in place. And so again, I don't have the connection to my Pi yet. This is not. This is coming from the you know, from my Amazon machine right now, which currently is not talking to my Pi, but that would be the next step, you know, plus some login. So those are some of the pieces I was sort of working with here for, you know, my sort of proof of concept teleop. But I might revisit this part 2 of that tutorial because I do want to see what that looks like when it's all finished. So that is one topic. Any questions on that before I pull up one other topic unrelated?
On your certificate, that's not registered globally, is it? Do you get to import it to your browser, or?
No, see, that's the key. I don't have to. You can go do it right now. Go to this address, okay?
Yeah.
Your browser will not complain. This is a real certificate.
Yeah,
For free.
Does it cost for free? Okay.
For free. Now, here's a catch. All right, the validity of that certificate is very short. Okay, again, there's sort of some mechanisms in place, and they give you the tools you need to kind of keep refreshing the certificate and to extend it. I think they give you one for 90 days or so. Don't remember the exact number, but that's kind of the catch. You get it for free. It doesn't live very long, so you have a little legwork to do, but that can be automated to kind of renew it.
Yeah, yours is valid from March 5 to June 3rd.
Oh, really?
That's what it shows. Yeah. Like
well, maybe it's already been auto-renewed.
Click certificate valid right there.
Let's see.
Yeah.
March 5. When did I pull it? Yeah, March 5 sounds about right. Maybe that's when I obtained it. Or maybe a couple days before that, and then it might have gotten. You know what? I think maybe it got renewed on March 5, or I pulled it on March 5. One of those. Yep.
Okay, I see. So it's this organization R3 that's verifying you are who you are. So that's the rub, right? So it's not VeriSign or somebody, it's R3. They've got the private key and you've got the public key.
Yeah, but what I guess what matters is whatever that root or intermediate authority is, it's already by default on your PC, right? It's not some shady thing that you gotta hack into. I've done that before. I've had to do it before. You install some root certificate on your computer, all kinds of crazy things, right? This is all standard intermediate certificates stuff that's already on your computer, and so this is signed off of that, and so every browser would typically be happy with those certificates.
Thank you. That answers my question.
Any other questions on this topic? Okay. So the other thing I was playing with, which it's a topic I frequently revisit, is sort of how to connect. What's the best way to connect the Pi to an Arduino or something similar, right? We kind of talk about that on occasion. And yeah, I've been using I2C with the Romy platform. I looked into sort of using serial, just a straight UART connection. You know, I mean, some of us probably have done that before. I've done it before. So I looked at that a little bit and played around with a few things. And what I was thinking, you know, in the past when I've done something like that, I've always come up with sort of, you know, fairly optimized, condensed, kind of packed kind of way of getting the data across, just so, you know, just so I don't have to send 200 bytes across the wire every time, you know, I want to send some updated information to the Pi for processing, right? But I was thinking, okay, if I can get the bit rate fast enough, you know, maybe I don't have to sort of use some sort of binary protocol for that, and can instead just use straight ASCII, right? Which has a benefit of, you can just kind of use a terminal program to inspect what's coming down on the wire, right? And you could sort of interact with it as a human, you know, versus, you know, any binary protocol, well, you got to have a piece of software on the other end that kind of implements the same protocol. So obviously ASCII-based stuff is, you know, takes up at least 3 times, maybe 4 times as many bytes on the wire, right? So that's obviously a concern. But so I played with baud rates a little bit and a couple things. To my surprise, so let me just pull something up here. So one test case here for me is my BNO 085 connected to a Mega right now, and I'm just using on the Arduino Mega sort of a standard library here to pull the data out of the BNO, and then okay, rather than just sending that across, and I have been sending that across in ASCII form, I basically say, well, okay, why not use that Mega, use the other inputs, because I'm a little short on analog inputs on my Romy. Okay, why not use the analog inputs on the Mega? Okay, you know, read them and send them across, and you can tell from this here, right? This is just comma separated values, all ASCII stuff that's gonna go across basically the serial port. Okay, yeah, pretty straightforward. You know, again, in a way, deliberately keeping it simple. Again, in the past, I would have come up with, or have come up with, some sort of binary protocol to keep this as small of a packet as possible. But then again, I'm just rethinking whether it's really necessary, right, to try so hard to keep the data so small, because, you know, I can't just crank up the bit rate, right? And that's what I did here. I mean, and to my surprise, things are holding up fairly well. So I'm running this at a megabit. Okay, the Arduinos, I think technically they can go up to 2 megabits just in terms of accurate, you know, baud rate generation. So I'm pumping this data out at a megabit, and it's going into the Pi on USB, right? I mean, the Arduinos have a USB connector, and so it shows up on the Pi as a, you know, as a USB UART. And so if I connect to that, right, it's the UART, it shows up as TTY ACM0, 1 megabit. And you can see from this command here, I always run everything at elevated priority just out of habit. Boom. So it comes across here, you know, nothing unexpected taking place here, except for, okay, at a megabit, and I haven't done the math, I haven't counted how many bytes I'm sending here in ASCII. You know what? I can afford to send even more here. I don't care that it's terribly inefficient, maybe, right? Again, these analog readings that are 10-bit each, they're taking up 1, 2, 3, plus a comma, plus a space, right? 5 bytes. That's just terribly inefficient. But you know what? At a megabit, maybe I don't care, right? And so again, sort of rethinking my approach a little bit from what I've been doing in the past. One thing I found though, and I've seen that in the past, there's sort of a delay whenever you go through these USB serial gadgets, and I have a little test program where I can measure kind of the round trip. I send a byte out and wait for that byte to come back. How long does that take? And depending on what USB serial converter you use, I mean, it can take a couple milliseconds. I mean, it can take in the order of 4 milliseconds, apparently, for the byte to go out and come back in. And it's got nothing to do with the software running on the Arduino, because I can do a loopback in hardware, literally just connecting TX to RX. It's just all the USB stuff and the USB serial gadget, right? That chip that's doing the USB to UART. Depending on what variety you use, the FTDI seems to have a little less delay than others. So you're talking anywhere from 2 to 5 milliseconds of delay. So that's one thing to keep in mind, because that means, right, what that means, and that's kind of what's bothered me in the past always, because if I want to send data at a high rate, like I/O data, readings, analog readings, or what have you, from the Arduino to the Pi, so that the Pi can make a decision and send the decision back, you got to take into account that you have it's going to take 5 milliseconds. And again, the baud rate is kind of not even that important here if it's high enough. It's just all the USB stuff that's going on adds to the delay for some reason. So it's you have sort of an upper limit in a way of what update rate you can achieve, so to speak, when you have it connected in that fashion. Maybe not a big deal, but that's just something I noticed, and I'm not sure. I played with a number of settings, but it's, again, you're dealing with a couple milliseconds there. So it is what it is. But I have a way of getting that down. But any questions?
Yeah, do you like include starting flags and ending flags, or how do you parse or synchronize with your?
So in this experiment right now, no, there's no framing going on. It's not going to be terribly reliable. So in a way, okay, you could look at it this way. Since I'm doing ASCII, my carriage return is
Okay.
kind of the end of packet, so to speak, right? Carriage return is the end of packet. Whatever comes after my carriage return is going to be a new packet.
Yep. Yeah.
Right?
Well, that's kind of a flag that you can look for.
Yeah, again, on a binary protocol in the past, they would have had some sort of preamble, a couple bytes, whatever, 55,
Right.
AA, 55, whatever, something. And okay, but doing this all in ASCII, you kind of, you use your end of line as a separator.
Yeah.
Chris, this is something I always found, because you're right, you can easily get in trouble with sending too much over your serial. But this was a one little factoid that I found is that if you're using 11, 115, 200 bits per second, one byte takes 80 microseconds.
87, yeah.
Yeah, so that's just something to if you keep that in your mind, if I'm.
So it does, except again, going through all this USB stuff, there's kind of a 3-4 millisecond additional overhead, and that's sort of per transaction in a way from what I found, right? So if I send 1 byte, it's going to take me 4 milliseconds.
You're saying that's on top of the shift register.
That's on top of it. So 1 byte takes 4 milliseconds. 2 bytes will take 4 milliseconds plus 86 microseconds. I mean, obviously the bit rate factors in here too, but there's kind of a fixed offset, right? A DC offset here of 4 milliseconds that if you're trying to do something really fast update rate, between the two nodes, you have to keep that in mind.
That was the other question I had. So you can get up to a megahertz for a bit rate, whereas like an I2C, what's the max? 400K?
400K, and I mean, I2C has its own advantages. I mean, the fact that you can have multiple slave devices is a huge advantage. The Pi has some issues with I2C, and there was only one port. The Pi is not that good at I2C is the bottom line, right? One port that has a bug, right? It's limited to 400 kilobits. On the other hand, the Pi has 4 USB ports. You're running Linux. Linux is really good at doing USB, right? It's kind of, again, one of the things you get with something like a Pi that you don't get on a microcontroller. You get 4 USB host ports, that are fairly flexible. You can attach stuff to, and if nothing else, turn it into another serial port. So I was just thinking, okay, why not take advantage of that, right? And look at that, because it kind of it's actually convenient. I don't know if I can. Well, there are some convenience aspects to that. Also, in the sense that I can, in this case, when I'm using the Uno, and I'm not sure if I'm gonna stick with the Uno or go to something else, but I can. This is now I'm running. So this is VNC into the Pi, running Visual Studio Code on the Pi. I can program it directly from the Pi, right? So I have firmware, obviously, that needs to run on the Uno, on the Mega, right? If I wanted to change that, I don't have to attach anything else or pull something out or whatever, right? Pull any wires, change any wires. I can just boom, right? Compile, download it, because this Mega is connected to the Pi over serial, and whatever tool you want to use, whether it's the Arduino IDE, command line, what have you, right? It's going to be able to talk to that Arduino and just program it directly. And the neat thing with the Arduinos is, right, I mean, that same connection can be used for programming, or can just be turned into a regular serial port, right? So right now, this moment, I went through a programming cycle, re-downloading this code, but now it's again a regular serial port, and I can interact with it that way, right? So this is kind of convenient that way, right? I don't have some other programming connection that's needed, to program that microcontroller. So I'm just, again, playing around with the different ways here, again, how to connect the Pi to other stuff for more I/O. Now, the other thing I tried was, because the Mega is not that fast. I mean, what I like about the Mega is it's 5-volt tolerant, including 5-volt analog inputs. So that's what it's really got going for it. So what I have here, let's see, where's my camera? Here. So this is a green pill, which is kind of similar to a black pill. It's not exactly the same, board layout. I think maybe some pins are a little different, but it's almost identical to a black pill. So it's an STM32 400 series, right? And what's neat about these guys is, what's neat about this one is, well, it's got a USB connector, okay? And these guys can act as a USB device, okay? Now, the blue pills are similar, except if you try this with a blue pill, your mileage may vary, because apparently on the blue pill, there is some hardware issue with the way, the USB signals are wired up. So you may or may not be able to use the USB connection on the blue pill. But on the black pills and this one, it works fine. And so what I'm doing with this one, same concept. This is going to my Pi here, this USB cable, okay? And on the STM micro here, I just enabled the feature that turns that USB port into a virtual serial port. So again, on the Pi, I have a serial port showing up. Now, the difference between this and the Arduino setup is there is no actual UART involved here anywhere. Okay, this is all just USB implementing virtual serial port protocol type stuff, right? On the Arduino, you have your actual, Atmega 2560 chip, and then you have a USB to UART chip on the same board, right?
Yes.
Some Arduinos have the USB built into the micro. So the more modern ones have that, but the traditional ones have like a separate USB to UART chip thing going on, right? This, there is no USB to UART chip anywhere. The only chip on here is the STM32. So it's got a USB peripheral. It has hardware support for USB, but obviously it has to have some firmware running to make use of it. And so I just enabled that feature in the IDE that you get from SD Micro, and with really very little work, basically have now a serial port showing up on the Pi, and I have an API that I can use on here, right, to get the data. So if the Pi sends data, shows up as an interrupt, okay, you hear 30 bytes that the Pi just sent, and I can call a function to send data back to the Pi. The key difference with this is, I was talking about that 4 milliseconds or so, latency that was there with the other setups. This one doesn't have that. So with this one, it takes usually just 200 microseconds for a byte to go from the Pi to the STM back to the Pi. And it doesn't matter if it's 1 byte or 30 bytes or 60 bytes, because again, on the wire, we're talking 12 megabits. And so, whatever overheads are involved, number of bytes, it really doesn't matter anymore. And that, again, has me thinking, what? It's not important how many bytes I'm sending. I can afford a real inefficient protocol in a way if I were to use this, because on the wire, I'm talking 12 megabits on USB. So I have a usable bit rate. I've measured it. I can probably get on the order of 5 megabits across here, usable, out of the 12 megabits USB. But the bottom line is I can afford to be really inefficient in the protocol, right? And it doesn't matter. And with this, the latency, I was surprised really about that. The latency is really almost nil, right? Like I said, just on average 200 microseconds sort of round trip. I'm almost doing a ping, right? I send, let's say 60 bytes, and I wait for the 60 bytes to come back, because the firmware on here will send back whatever it gets. And it takes, again, usually just 200 microseconds. And so that was, I was surprised to see that, pleasantly surprised. And so I might consider that. It doesn't have any pins as the Mega, and the analog inputs are not 5-volt tolerant. So that's the main downside, right? On the Mega, everything is 5-volt, including the analogs. On these guys, I mean, the digital inputs are 5-volt tolerant, I believe. Just the analog is limited to 3.3 volts. So that's.
Hey, Chris, is that a Maple board? Is that a Maple board clone?
Maybe that's what it's called. Again, this is something from Amazon. I can send a link.
Can you see the number on the processor? Is it a 401?
Oh yeah, so this is a 401, STM32F401.
401, yeah. Yeah, I always thought those were called the black pill, but now Adafruit.
Yeah, like I said, it's almost identical to a black pill, but instead of 2 buttons, it has like 1 button and 3 dip switches, and so there's some subtle differences. But for all practical purposes, just call it a black pill.
Yeah.
So again,
in the chat when you get a chance.
Yeah, so I mean, this is again just for I/O expansion. I mean, one bottleneck, so to speak, I just ran into when I was trying to do something, right? So I'm talking from my Mega to the B&O 85 over I²C. Again, it works pretty well. Now I wanted to add a little OLED display. Well, turns out these OLED displays are pretty slow, right? One screen full of stuff takes 60 or so milliseconds to get across, right? So now, okay, it's great that you can attach multiple things to an I²C bus, but if one of those things is just dead slow, you're gonna have a bit of a problem when you're talking to something else and you're trying to pull some data out really fast, right? So I need more I²C ports, right? Is part of my problem. I mean, I kind of like I²C, but I have this mix and match of stuff. Some of it is real fast, and I need to pull data real fast, and some of these things are really slow. And if you try to get that all on one bus, it's gonna get real tricky to make this work, right? I'd have to send like one character at a time to my OLED. That's gonna take a millisecond, and I have to allocate time on the bus to do something else, and then send another byte to the OLED. I mean, it becomes painful, right? So that's another reason. Unfortunately, the Mega only has one I²C port. So that's the other benefit of this guy or similar ones, right? They have more than one I²C port.
Well,
So,
Chris, I have a couple questions. First of all, you're aware that the Raspberry Pi does have two I²C buses.
you're right. I have never tried the other one because they're saying you're not supposed to sort of touch that one, but I guess yeah.
Well, that's the only reason you don't touch that one is because it's generally used for EEPROMs on those boards that have EEPROMs, like on the hats that have EEPROMs. But if you're not using that, you can use it. In fact, I've been playing with the little Pico RP2040, and because I've got everything already, all the stuff I've got I²C is on the standard port 0. That port 1, which is on pins 27 and 28, is just a regular I²C bus, and so you can put it on that. And then secondly, as Adafruit, what's the woman's name that runs the company, the pink hair?
Limor something.
In any case, one of her
Limor
videos, they
Green.
were pointing out that they like OLEDs, but that they are very slow, and that if you want to have any kind of performance, you got to go to SPI. And so I've got those little mini TFT displays, which are SPI displays, and they're, that's what I'm using as little console displays on my robots, and they're lightning fast. So I highly recommend that if you're not using your SPI bus, just get one of the little Adafruit ones. They come in about 5 sizes, and they're very fast. You won't even, I can't remember the speed, but they're quick.
Yeah, that's a good point.
Yeah, the weird thing about the OLEDs is they have no memory, so pretty much if you're going to refresh the screen, like say with more data, you've got to blank out that whole section of screen and then rewrite it.
Oh.
So, and that's why the OLEDs don't work with like the Uno. Uno doesn't have enough memory for it.
No, I mean, I was driving that OLED. It's a 28 by 32 pixel OLED. I can drive it from the Uno. Maybe it depends on what library you're using, but if that small OLED I was using with the Uno before. But okay, yeah, I've seen the SPI ones before. You're right. That's something to consider, and I should really try that second I²C port on the Pi. But with all that said, I still need more I/O. And on my Romy, I'm limited because it's all tied up for other stuff that's part of the Romy control platform. So I need something to get more analog inputs and more digital and a coprocessor for certain things. And so that's kind of what I was looking at, connecting Arduino stuff to the Pi, which a lot of us are doing. And so I'm just exploring new ways of doing that, basically. The main takeaway is, you know what, if you crank the baud rate up high enough, why not use an ASCII protocol? Because there are other latencies there that you can't do anything about. So you crank the baud rate up, you can afford to send 100 bytes across, and you know what, it's not going to take that long. I was surprised to find that in my little ping test where I send, let's say, 60 bytes to the Arduino, and it'll send stuff back as it's coming in. I can do that at 2 megabits. I was surprised that the Arduino Mega was not losing bytes there at 2 megabits, because that's a byte every 5 microseconds. Okay. I mean, I wasn't doing anything else on the Arduino Mega, so there's nothing else generating interrupts or disabling interrupts. So I guess it really should work. But you know, I was surprised that it did work. I mean, a little bit. So at that rate. So it's of course, if you have more going on an Arduino, you can't sustain sort of that kind of throughput, right? You'd have to sort of space out at least when you send stuff from the Pi to the Arduino. You know what I would be doing if I run it at a megabit or higher. I'd send a byte, wait 50 microseconds, 20 or whatever, something, right? Send the next byte, and usually the data that you send to your IO slave isn't all that much, right? It's would be a motor command. Maybe you're toggling some discrete output or something, right? Or maybe you are telling it to generate some PWM on some pin, right? So you're not really sending a lot of data in that direction. It's all the other direction, right? If you read all the IO that you're reading from the IO slave, you know, a bunch of analog inputs, a bunch of discrete inputs, encoder data, other stuff, right? So that's where the bigger amount of data is there. And, you know, so the Pi doesn't care how fast that's coming in, right? So you can afford to send that from the Arduino full throttle, right? You wouldn't have to sort of artificially add some spacing between the bytes, right? Because the Pi doesn't care. It's anyway just USB on the Pi end. But when you're sending it the other way, you'd have to, you know, probably be a little bit careful.
Yeah, I think, Chris, you're right. There's quite a lot of us actually playing with this idea of like master slave or co-processors and all that. And I've tried a variety of things with a wire protocol over Arduino and all that. And I'm running into kind of the same set of issues as you are. And I guess I can kind of give you my little report for the week is that I've been playing with the little Pico RP20, the new Raspberry Pi, and you plug it in, or you can plug it in. What I'm doing is plugging it into the Raspberry Pi over USB, and I think it's called Minicom, and you can basically, you get a TTY terminal into it, and but again, it's and the one benefit of this RP2040 is that you can program it, at least from my perspective, a benefit is you can program it in MicroPython rather than CircuitPython or C++. And for me, I'm trying to have the same language across everything I'm doing, rather than having C++ on the Arduino compatible and Python on my Pi. And so this RP2040 is in MicroPython. And I'm just now this week struggling with the first attempts to try to talk to it again, either over USB, over serial, or whatever. And I'll be kind of curious to see what anybody in the group can do in this area. The other thing I did was I've just put an order into Adafruit for the two different what are they called? I can't think of the brand name, but they've got two ESP32 boards. The one's the Tiny Pico and the Feather S2, which are both ESP32 with Wi-Fi boards, you know, a little Feather board and a tiny size board. And they both are also MicroPython boards, which is the appeal for me. So as far as I can tell, I'm kind of getting away from the Itsy Bitsies and the Arduinos over to either the RP2040 or one of these ESP32s in MicroPython, with the idea that one of those three boards will be able to be my slave board. But which protocol, I don't know yet. I've started to play with actual I2C, but I'm down in the bit banging kind of thing, and it doesn't seem very efficient. There must be somebody out there who's written a little higher level library for communicating between them, but I've not yet found it yet. I'm literally at the bit banging level where I can connect up and I can demonstrate that I've got the connection, but then I'm sending bytes back and forth, which is, I know for a lot of you guys who went back a few years, that's the norm, but for me, it's kind of painful having to send bytes.
I mean, one advantage of UART over I2C is that it's kind of full duplex, right? If you only want point to point and not sort of some multi-drop. And so you know, in a way, I mean, I2C does have speed limits and you know, is a little bit trickier to get right in hardware and software. So I'm really thinking, okay, UART might be the way to go. Um, I know,
So-
Carl, you did Spy, but I don't know how you got that to work, because, you know, if your Spy master just pumps stuff out at 10 megabits a second, your slave better have some DMA or something going on, right? So you can't do Spy
no.
efficiently unless you have a real beefy sort of recipient.
Well, that was the, so let's just say it's remarkably robust for someone who did that for the first time and got it to work. It's remarkably robust, but it's not anywhere close to taking full advantage of the Spy, because what I understand about the Spy is that you can actually you can send bursts of bytes, and multiple bytes in one burst. But the way I set it up, specifically because of what you described, and I wanted the Pi to be a master and the Mega to be a slave. Well, the Mega can only accept 1 byte at a time, period. That's it, no more, 1 byte at a time. So I very consciously designed this proprietary protocol so that I send out a framing byte at the start, the kind of a byte at the end, and that way I can tell if I've started a transfer and if the whole thing has succeeded or not, without counting bits, but I can tell. And the thing is that I timed it. I figured out with all the stuff that, so I figured out that if I just run a bare Mega with none of my other code going on, I can get like 500 megabits or megabytes a second, something like that. I mean, I can get pretty fast, but all that is a loop back. I can't do anything else. There's no time. So I figured out that the way I want to run it, the low-level real-time stuff has to run at 50 hertz on the Mega. So that gives 8 or 10 milliseconds, whatever it is, for a compute window each time. And then, but that leaves a certain amount of pad to play with. So what I did was that I timed you can control the master side on the Pi, since it's in charge of the communication and initiates the transfer. So I set it up specifically conscious of the timing on this Pi, so that I have enough windows so that, I mean, I was looking at it today once I got the ground wire fixed, and after 10 minutes, and it was running like, I don't know what it is, 20, 30 hertz, it transfers byte exchange, a 20 byte packet, it exchanges with the Pi, 20 or 30 hertz. And out of 10 minutes, I had missed like 10, 15 transfers that I couldn't trust. And so the way I think about it is that because the real-time loops that I have, low-level real-time loops, the way I think about it is they only expect updates relatively infrequently, and they're anyhow multiple samples in between each Pi transfer. So if 1 or 2 of them get screwed up now and then, it really doesn't hurt anything. And then also with the Spy, I mean, you talk about USB being full duplex, but so is the Spy, right? For every byte that goes one way, there's another byte that comes back. And that's a part of my protocol. It's full well intended to take advantage of that. And I kind of mapped out, like, in my own mind's eye with the donkey car project, what bytes would I want to have going which way? And there's some bytes that go in both directions all the time. And then there's a handful of bytes that are flexible. So I have like an ID byte that says, well, for this transfer, the specialty bytes are XYZ. For the next transfer, they're ABC. And in that way, I don't know, it's not a great protocol, but it's pretty flexible and it's pretty reliable. And I want to go putz with I²C, and because it's a standard versus what I wrote, and a lot of devices use it. And then, Chris, it's kind of interesting what you've done now with the virtual USB. And so anyhow, that's a long-winded non-answer to your comment on my SPI.
Yeah, I mean, there's a lot of different ways to do it, but I've looked at Spy in the past, but I was looking at how can I use Spy, the Pi as a Spy master, and my Arduino or Mega as a Spy master as well, right? Because that way, and there's something in between that acts as almost like a dual ported memory kind of concept, right? Both of them can pump data into there at whatever, 10 megabits, and pull data out of that at the same time, right? Without anyone having to worry about the other end keeping up, right? If you were able to do something like that, then you could take full advantage of SPI, right? Because you could crank it up to multiple megabits. And so one idea I had in the past was to use as a instead of actual dual ported memory, which I'm not sure exists for this setup, use one of these SPI to UART chips from Maxim, right? It's like a UART chip. You talk to it of a SPI on one end, out comes UART signals on the other end, right? So use two of those end to end, have the UART configured for a crazy high bit rate, right? So I've thought about crazy stuff like that just to have a real fast connection between those two nodes without losing data or whatever. But it's all too complicated. Keep it simple.
It's kind of like a hardware message board.
Probably handle that, right?
I think you need an FPGA. That's all that you're missing between those UARTs is an FPGA.
There you go. Something new to learn. No.
Yeah, Adafruit
So-
their black pill based on the 411. I don't know if anybody saw that, but super fast part, has all kinds of memory in it.
Yeah, the cool thing about those parts, again, they got multiple I2C ports, they got multiple SPI ports, they got multiple UARTs. So you could almost use it also as a communication hub, right? Because it could, it could branch out to multiple downstream devices, and you talk to it over UART and you just get back what you want. And so that's nice about the SDM parts. They're fast enough to handle all that, and they've got enough communication ports to give you a lot of options to connect other stuff. Now obviously there is a bit of software that you need to write to sort of really take advantage of it. That's kind of the hard part.
Yeah, I think any of the displays are, they're nice, but it seems like whenever I use one, it does slow things down because, it's not like a character display, and the character displays are not fast either, where you're just writing one byte, it figures out, okay, that's the letter A, and which dots do I turn on? You're going through like Adafruit's graphics library, or something that's okay. Going to figure out, okay, I picked this size font. I have to turn on these dots for the letter A, and that's supposed to show up in a certain color on a certain starting pixel on that display.
Exactly, and that translates into a lot of transactions on the I2C bus. And so if you want to have multiple devices on one bus and one of them is a slow poke like that, it's it can be an issue.
Yep. Or just in the in the cycle time, if you're trying to write out a full screen of data every 50 milliseconds or something. I know with the OpenMV H7 camera, if you put the display on the back, it just about cuts the frame rate in half just to refresh the image on the little display. So,
well, Ray, one of the things about those little TFT displays, the Adafruit ones that I've been using that are SPI connections, is that it's not on the I2C bus, it's SPI, but also that it's actually connected to the Raspberry Pi as a TTY. So it's receiving TTY signals. So it's just getting ASCII, as far as I understand. It's not like there's no driving happening on the Pi. I think, as far as I understand, in the mode I've got it in, it's being treated as a TTY. So,
but that's just the software. That's just the software making it look like that to you. On the, if it's a SPI connection, someone is blasting bits over the SPI bus to that display that just make it look to you like it's a terminal. That's all just hidden in the software. Just magic of Linux.
Yeah, I'll have to take a look at the software. I thought it was actually. Oh, you must be right, because there's
a device driver. There's a kernel driver running that's going to make it look like a terminal.
Yeah, because it's a SPI connection. You're right. Yeah, but it isn't contending on my I2C bus at least.
That's all
So
from my
one
side.
thing, Chris, one thing I was wondering about, because I was planning on using your methodology to connect my Pi with my Mega, and I was planning on transmitting ASCII. But if you go to that really high baud rate, do the processors on either side have much time left to do anything important? I mean, the Pi's got to do its thinking to come up with the command it wants to send, and the Mega's got to do its keeping track of all the optical interrupt.
Right, but you're not
sensors and everything.
sending. So you're not sending data continuously, right? You're sending it in bursts, right? So so you're sending a packet, a line, an ASCII from the Pi to your Arduino. Let's call it 10 bytes, 20 bytes. And then you wait almost an eternity, right? Tens of milliseconds, right? Before you got something else to send. And same thing in the other direction. Your Arduino is reading all the sensors, and then at some rate, whether it's 20 hertz or 50 hertz, or I mean, I would usually go with 100 hertz, right? It's sending 20, 40, 60, 80 bytes across the wire at the high bit rate, right? So you want the high bit rate so that it doesn't take an eternity to send those 80 bytes, right? That's what I'm after. I want those 80 bytes to go across the wire
super fast,
instantaneously, right? So that the
But the
Pi can do its
the high
thinking.
bit rate doesn't affect you.
Well, during
So you
during
haven't
the
found that the
time
high bit rate
during the
affects
time when the bytes are going across the wire, you're gonna have interrupt firing like crazy for sure. So yeah, both sides are gonna be a little bit busy, but it's eating time, it's eating away from whatever else it has to do. But in the grand scheme of things, you still have plenty of time left on both ends, right? Or especially on the Arduino where you don't have that much time, you still have a lot of time left to do everything else you're doing. That wouldn't be a concern, I think, for me. I mean, I have never done it at this high bit rate. I have to say, again, in the past, I was limited to 115, 200 because I was using Bluetooth, and I haven't found that to be an issue, with the Arduino sort of keeping up with the sending of the data and the receiving of the data. And I was almost doing it continuously. It was short blips of time, short packets for sure, but at 115, 200 baud, right? Now you got let's say a 50 byte packet or whatever it was, I don't remember. Now it takes quite a while to send that 50 byte packet across the wire. And by the time you're done with that, you're ready to send the next packet. So it's almost continuous sending. And yes, it does take some time. But as the other Doug pointed out, right, you get it's 86 or so microseconds per byte. So you're going to get some interrupts firing. But in between, you still got plenty of time left to do everything else.
Okay, thanks.
I tried something like this. It's like 1 megahertz baud rate, and I was initially trying to load all the motor interrupt data to my PC. So yeah, I do get into trouble when some of my motor is fast, like the interrupt rate is fast, and I can't load stream data at the same time. I have to limit it to like 10,000 data points. Otherwise, it's not sustainable. It's like the Arduino will lock up. And my understanding is it's an interrupt, right? When I'm sending the serial, it is using interrupt, and my other interrupt for this motor interrupt. I mean, it's like I'm taking two channels. I mean, I'm taking the both phases as well. So yeah, I do have to stop the sending. Otherwise, it'll lock up. So,
It's quite possible, yeah.
Yeah, and there's buffers on all of the serial ports. So what is it? I think it's at least either
Not on the at megas. You've got a buffer of 1 byte.
Really?
Now you don't have a FIFO. It's well technically 2 bytes, right? You've got the shift register, or as the bits are coming in, as the bits are coming in, they're going into one register, and the last byte that you've received is still there. So you have technically 2 bytes, but when the second byte is finished receiving, boom, you've lost the first byte. So call it a byte. You got to read that byte out in time, or you lose it.
There's no like ring buffers that are built in.
Well, in software, right?
Yeah, in software. Yeah.
In software, absolutely. But I'm saying if you've got other interrupts coming in, right, and blocking interrupts, and now you have data coming in on the UART, and your interrupt is not firing in time. Meanwhile, you get another bits coming in on the UART. You're gonna lose a byte. So like Gian was saying, if you got too much stuff going on, yeah, those baud rates. If you don't leave a space between the bytes, right? If you're sending bytes back to back at 1 megabit with other stuff going on, that's not going to work, right? So that's I wouldn't expect that to work. So you'd have to space in the direction from Pi to Arduino. You would have to add some spacing between the bytes to make it work at high baud rates.
Yeah, see, and that's just what I did, and I spaced it so that most of the time it works. And I designed it so that I know if a transfer fails, and I designed it so that if a transfer fails, I just treat the data as garbage and I don't use it, so it doesn't corrupt anything. I just drop it.
Do you know if it's 1 interrupt per byte or 1 interrupt per bit on the Arduino?
It's 1 interrupt per byte. I mean, it's not per bit. Otherwise, it's, it would be
way too many.
Then it would be a bit banging a serial port. I mean, you can do that too, but that's something else.
I remember seeing something like modifying the software buffer size. I think it's like 64 byte or something. But yeah, I mean, I tried, it didn't work, but I don't think it was, so yeah, basically I increased the 1 megahertz baud rate. That solved my problem. But,
Well, I can tell you it is 64 bits, and I frequently use 512. I mean, you can change it without trouble, and so that's something you can do. Also, I believe the serial port, otherwise the transfer of the information is run in parallel with the actual processor, because it's a peripheral. All right, so it's not using up the processor, but the processor, you do have to read your buffer, or you'll overrun your buffer. And what'll appear to happen, I did this when I was doing LiDAR data. You would see, okay, I'd get data, and then all of a sudden it would skip, and I'd pick up, say maybe I was at angle 200, and then all of a sudden I'm at angle 300, and it getting data again. But all that data between 200 and 300, the buffer was overrun, and it was just going off into the nethers. So that, so it's now I've never tried to run something at 1 megabit per second. So I can't really tell.
Doug, was it easy to modify that buffer size?
Yeah, it's just you have to go to the Arduino core and change it in there.
I looked up. I mean, I saw some article followed it, and I was querying that like how many buffer does it have left? I didn't think it worked for me, so probably I used the wrong guidance.
Yeah. Well, I'm just going to say that I believe it's, if I remember right, it's a dual ring. Otherwise, you fill up one buffer, and then you immediately start filling up another one where it reads the first buffer, and then ideally you get so you finish reading the first buffer by the time you filled up the second buffer, and it just keeps switching back and forth.
Yeah, usually isn't it done with pointers though? You have pointers. So if you're whatever
Yeah,
it
I'm
is,
sure, I'm sure it is done with pointers.
if your input pointer overruns your output pointer, you're screwed.
Yeah, well, they have some sort of recovery mechanism.
Yeah.
I mean, but like I say, it will. But you're right. When you do that, everything that's coming in faster than you can take it out is just being lost. It's just like a bucket, and it's just flowing over the top of it.
Bits are piling up everywhere.
Yeah, yeah. I'm actually interested in some of the stuff you guys are talking about running that fast. I haven't really ever tried to run anything that fast. Because usually the baud rate that I'm using is set by whatever sensor that I'm establishing connection with. I don't really have a choice. I have to use whatever their baud rate is. Like for LiDARs, it's very typically 115/200. So anyway.
And again, with the STM32, the whole baud rate thing kind of is not applicable because everything is it's just a virtual serial port on top of USB, right? So even though you have to supply a baud rate parameter, let's say to utilities like Miniterm or Minicom and whatnot, right? All that gets ignored. It doesn't. You can supply 9600 or whatever you want, because whenever you're dealing with a virtual serial port, there is no UART anywhere. There is no bits on any wire that take X number of microseconds. It's just USB packets flying back and forth. And whoever is the slower end of the two, that's going to determine how fast you can get those USB packets flying around. And so, like I said, I was measuring in my round trip ping echo kind of thing on the order of 4 or 5 megabits is what I was getting, between my Pi and the STM32. And so that's, again, there's no, baud rate setting that has to match, or or buffers that can overflow in a sense. I mean, I suppose there are probably USB buffers somewhere for sure, but it's when you're dealing with something like an STM32, even UART wise, it does have a 5.4. I'm pretty sure. I don't know how deep it is, but the UARTs in the STM32, I bet you have at least an 8 or 16 byte deep 5.0. I'd be surprised if they don't, right? So then you don't have to worry about that much. If your interrupt gets delayed, no problem. And they have DMA as well. Again, the software side gets complicated if you don't find the right libraries. But, so that's, I mean, those parts are just, infinitely more capable than the Atmegas. That's the bottom line.
Well, yeah, no question. The nice thing about using Arduino, though, is you just use a serial port. You just use serial.print. If you want to use your own, if you want to use STM, you're going to have to write that.
Well, there's soft serial. I mean, that's written for you.
No, in the library, it gets a little more tricky. I mean, but with something like Platform IO, you can run the Arduino core, the Arduino framework on STM32, right? So then you can make it look like an Arduino if that's what you want, but then you can't really take advantage of all its capabilities. So that's the problem. If you want to take advantage of its capabilities, you got to go more bare metal. You got to go straight to the STM IDE, the Eclipse stuff. And it gets a little bit more tricky to pull in all the standard libraries. And that's why I've put the Mega on my Romy, because you get a gazillion libraries. I don't have to think about it. Use the OLED library, done.
Yep.
It gets a little bit more tricky to use that library on the STM32 in sort of bare metal mode, right? Unless I run
translate it basically. Yeah, you have to read. Yeah, it's a lot of time. Unless you find somebody who's already done it.
No, I mean, the people have done it, right? I mean, it's just those libraries. If it's meant for Arduino, it expects other APIs to be there that are coming from the Arduino framework, right? So it gets a little tricky to use some of these libraries that way. But that's the unfortunate thing, because there's a lot of power. You know, you can leverage these parts pretty well if you're going more bare metal with the STM IDE and maybe with free RTOS, which again is just you check a box and the feature is enabled, right? The USB stuff I was doing in the STM IDE, I checked the box, done, you know. Now I got USB. Okay, I call this function to send data, done, right? But using those standard Arduino libraries, well, now you got to fiddle with it.
Yeah, there's another approach too. You can extend a little bit better, and that's to use embed. That's also something that's another option.
How about Espruino? Is anybody on here? I don't think so, but has anybody messed with Espruino?
Nope.
Mhm.
So
No.
is that a crossbreed between an Espressif and an Arduino part?
I can guarantee you that I will, but I haven't gotten very far with it yet. But it's basically like a Node.js. It's JavaScript for microcontrollers.
Oh.
So the guy has basically a C-based framework that ports on all manner of different hardwares, STMs, NRF chips, almost anything really, SB32s, MC32s. And the thing I like is that since it's JavaScript, oh, you got one. Yeah. Since it's JavaScript, it's inherently event queue driven. And from whatever I can tell, this guy's done a pretty nice job of the framework so that and it's meant for low battery powered stuff, or you can run it at full power, like power hungry stuff. And in low battery mode, he very carefully puts the things to sleep to conserve battery, and then only wakes it up whenever event triggers it, which you can easily get at high level abstract code. Or at full power, I mean, I think you can. I want to see how close to the good processing bandwidth of these more advanced chips you can get, but I bet it does pretty good, really. It seems like he's done an efficient job with it.
Well, I've just played with mine a little bit. I was even thinking about putting on a robot. I mean, they do have Wi-Fi. There's actually a Wi-Fi thing on the back.
Oh, yeah, yeah.
Yeah, they're pretty amazing. And I just basically played around with Blink and stuff like that on this one. But
Yeah.
for me, I hate to tell you, but I have a lot of web background. I was actually like HTML and all that. And I don't think I could stomach programming a whole robot in JavaScript.
It wouldn't work for you?
No, I think I would just give up at some point and just go off and, like, I don't know, get into farming or something like that. I don't think that my relatives are farmers, and I know it's not that easy. But no, I just couldn't do a whole large JavaScript project. I mean, I've got JavaScript stuff at work that, like, I'm working with stuff at work for JavaScript, and honestly, even if you're a good JavaScript programmer,
but you're talking front end, or are you talking Node, or are you talking back end?
Well,
Whatever.
yeah, you can load libraries on this thing and kind of move up a little bit further, but you're still, put it this way. I just downloaded. Has anyone heard of React?
Yep.
It's a framework for making web pages. It's single page applications. And I just did a React application, which was Hello World. Yep. And so you download this small file. It's about 10 lines long, and you run it. And it uses NPM, the Node package manager, and it downloads everything so that you can do Hello World. And there's 47,000 files.
Oh yeah, it's huge. Well, that's React though.
Yeah.
Murray. Welcome to like 2016, because that's when all this stuff started coming in, man.
Yeah, I know. And my point is that, yes, on this little chip, you could get away with just JavaScript. But if you wanted to step it up to the next level, there's lots of libraries. But as soon as you're in JavaScript, everything just kind of seems to explode. It just, in terms of complexity.
Yeah, I have the same problem with Angular. I mean, we've got a build that takes 20 minutes. 15 of those minutes is downloading and ensuring we have the right packages and building the JavaScript files that'll get bundled in so that our Angular app will run. All the actual real server code and all that's doing what I think the hard stuff is. It takes just a couple of minutes to compile. All the rest of that is Angular and doing the JavaScript dance. Well, it's
Well,
time it gets converted to.
kind of what it came down to for me was that, like, I know that some people here don't really care much for Python, but I've actually enjoyed Python programming, and part of it is that, and because I'm not actually in a big environment, I don't have to create. You're supposed to in Python create your own environment every time you create a new project, and that way you can have multiple versions of libraries and all that. I'm not doing that. I'm on a robot with one environment, so it's a little bit easier for me. And so there's a bit of I can apologize for those who actually have to work in more complicated, like, server environments. But Python for me, it's like I get a server, I should say a sensor. I download the library for it, install it. I've got that running in, let's say, 10 minutes. Everything seems pretty easy. And I actually, my memory of playing with this thing was, as soon as I tried to do anything a little bit more complicated, it just got way more complicated. But I'm not a serious JavaScript programmer. I'm literally right now, as you guys are talking, typing in JavaScript. I've got a project. And it's like, oh God, yeah, I'm just not.
Well, I feel your pain. We'll see. That's one of my back burner. I don't know when I'll get to it.
Yeah, it's a
At
nice
least
little.
someone else to talk to about it.
Yeah, if you could keep it simple, it's a lovely little chip. I do like it, and it's got Wi-Fi built in, and it's got power mode, drops off, and I can't remember. It's a low power device. It's a great little chip if you're a JavaScript programmer already, I think.
That helps a lot, I'm sure.
Yeah.
Yeah, because it's not JavaScript is not C. That's for sure. They're kind of worlds apart. It's a different mindset.
Yeah.
Okay, so we haven't heard from Harold in a while, or Ray, or I think Kareem, or Doug D. So who's got something to say?
I mean, yeah, I can say a little bit, or go with whoever else is going. I don't care. Doug D, you can go.
I don't have anything. I'm out traveling around this week. I'm coming to you from Lake Murray, Oklahoma, and I just don't have anything. I'm a slurker today.
Lake Murray, enjoy.
Yeah, it's very, very nice.
Give me a second here.
That's a lake, not a person, by the way. It's a nice place up there.
It is really nice. We're really enjoying it.
Are you camping, glamping, or you at the resort place they have?
There's something called floating cabins next to the resort.
Okay.
So it's like a house almost. And my friends, we came as a group, and they all brought their RVs. I refuse to do RV. And I don't know what my bandwidth is sounding like. I'm on this really bad Wi-Fi here. So I canceled the video because I didn't have the bandwidth to transmit it and hear you guys.
Yeah, that's the joy of glamping. Ladybug.
Yeah, so if you'll click on my page, my thumbnail there so you can see me. The wife came home, I don't know, end of December. And she goes, well, I went to Michael's and I bought this $5 bag. It had these, dumpster diving kind of bags, right? It's for $5. She found a bunch of stuff she could use. Then I've already took the box away, but you found this thing called a Kamigami. Kamigami. Yeah, Kamigami. And the idea behind these things is it has a standard module in here that's got a little a port for blasting things. It has a couple of motor drivers and some really funky ways to drive these things. And it takes about an hour to put this thing together. And this is stationary, but it's got the motor that goes around in a circle on each side of this thing, and it drives like a pig. But it does do some fun things. It comes with a Windows. Let me see. I'm getting messed up here.
Android.
It comes with an Android little device. After you turn it on, you connect it to Bluetooth. It's got rechargeable batteries in the back of this thing. And then you can have it run. You can have it, like, for instance, it gives you one of these things. If I want to move forward, it moves forward. It's actually pretty quick, but because of the way the motivation stuff works, you can't go in a straight line. You can't go in the left line. You can turn on the lights and change the lights a little bit there. Kind of hard to see. And then you can have it go straight back and a few other things. I usually put it in dance mode on occasion. Yeah, let me make sure things up. And so when I'm in dance mode, I tell it to dance.
This sounds like a cat toy. I mean, I can imagine a cat just loving this.
Well, I tried to trace some dogs a little bit and that kind of stuff. It was fun. They also have like a tag or a battle mode, which basically goes around and gives you a little button to shoot things. And I think it's blasting some IR out the front of it. There's like 10 different. I went and looked these up on Amazon, and there's like 10 to 12 different shells they put on here. I mean, the bodies are all the same, right? But with a little bit different identifier chip so it knows which one shell should be on top of it. And these were $60 in 2017. And now I got them in a throwdown bag for $5 that included a bunch of other stuff. So I figured that's pretty cool. And right now you can get them on Amazon for like $10, $13 a piece, somewhere between $10 to $15, the different sides. And I'm like, okay, it's cool, just fun to play around. And that was kind of fun playing with that thing. The other thing that I was surprised, and I will tell you, I lit this up on my stream the other day. This is 93 RGB LEDs. It calls them NeoPixels. And not too surprising. I like how it came out and it works and all that kind of good stuff. But the surprising thing is, hold your hat, folks. This thing was shipped I ordered it and it was shipped from Shenzhen on a Tuesday, and it showed up at my door Friday afternoon. I'm pretty impressed by that.
That's
awesome. Amazing it to me. DHL. The other surprising thing was this. I won a contest, which comes with some hardware, and this is a big old crazy thing here. It's a Nordic. There it is. You guys can look it up about as easy as I can type it in. Developer's kit. And I still have, I've got some buttons to blink on it. But there's a programmer, it looks like it's using Eclipse under the back side of it. And for building this thing up, I got that. I got one of these TFT displays that you folks were just talking about. Yep. Passive touch on there. And I've got a Bluetooth low energy dongle to plug into my laptop so I can connect all this stuff up together. Doing all of that. I won it because they liked my idea of a contest for a thing I want to do. I got one of these, or one of those. That is a heart rate monitor and SpO2 monitor in a single package. And the idea is I am going to take this thing, use my TPU, make myself a Pip-Boy 3000 or so, somewhere along those lines, with the screen on top of it, and have it be me some kind of Fitbit thing or whatever, and hopefully I win some prize money.
Oh, cool.
That's what's kind of going on in my world at the moment.
Neat.
How much time do you have to do that, Harold? What's your deadline?
May 20th is a deadline. So not a lot of time, but should be plenty of time for me to get going. But this is all coded in C++. I can pull up the development environment here, I believe. Well, I could anyways. 1 second here. Yeah. Okay, maybe it's not there yet. No, I've got my screens with the NDI. There's some weird going on with the NDI detector on it. But I was going to show you the IDE of the thing. But it really looks like some Eclipse based stuff and probably an embed based thing in the processor. But we'll see what else going on that. It's got buttons and analog current sensors and a whole bunch of things on the board. The actual chip is just this thing right here. This is actually the development kit board on it. And it's
Because I remember though, those NRF chips, some of them are just every bit as capable as the STM chips. So they're, I mean, you've got a lot more than an Arduino, I think, on that board there.
There's a lot more.
Definitely.
Things like it's even got nice little switches on here where I can tell it to come off the power comes off the LiPo or the USB or whatever the VCC that I plug into it at, battery, and a whole bunch of other stuff. There's a lot of niceties on here that I'm going to, and I just unpacked it last night. And you know, when you get a new board, you're not used to playing with a whole lot of it. You're like, okay, that's blinking LED. Cool. Let's get some serial. How in the hell you do that? You know, because literally when you plug this board in, the IDE says, okay, download this hex file to that board. And it looks like a drive on your computer to put the hex thing. It puts a hex file out there. You reboot it, programs it, right? That kind of thing. Hit the reset button. And so I've got a lot of learning to do all that to figure out all that stuff out. That's about all I got going on. Yeah, about all I got. I would just and by the way, this thing shipped from Oslo and was here in like 3 days as well, 4 days as well. And I'm like, DHL's kicking it hard, man. They must be needing some dollars, you know. Must be needing some serious.
How much shipping do you have to pay for this fast shipping?
Oh yeah, the Nordic stuff I didn't pay anything because I won it in a contest and somebody else paid it. This, the LEDs. I also got yeah, the sensor. Oh, the sensor. And these are all from DF Robot, by the way. The sensor. And I was just going to buy the sensor. And it was going to be the minimum shipping was $15. And I'm like, well, the sensor didn't cost me but $9. And I'm like, okay, let's do something else, right? And so I got to looking around and I decided, oh, where did you go? I just had all of you here. Oh, got them. I decided I wanted some of these for test clips around. So, you know, they got grippers on the ends.
Right.
You know, and females here for debugging. Those are like $6, $7 for a pack of like 10 of those. And then this whole put together. It's really made where you can clip the thing and take it apart. But I want to use it as a big annoying dot thing when work things show back up as timers and other things. But this whole thing was like $20 for it's put together in all the 93 I call them NeoPixels, but there's those WS 2018, whatever they are, RGBs. And I was just going to get the one thing, but I said, well, if I got to pay $15 shipping, let's make it worthwhile. You know, I'm sure I'm not the only one ever to say those words. And away we went. The sensor does work. I'm going to have to calibrate it pretty good. I tested it on all my fingers, even where I really want it to on my wrist to do some things. And there's a power level rating there's an infrared sensor and an LED that lights up on this as well that does some of those checks. And there's power levels and all that you get to set depending on how much juice you have to shine into your skin to get some reflectivity back off of it. So I've got some work to do with that too. And I think it should be fun anyways. Or maybe I just attach it to my ladybug over here and just RGB it everywhere and just have a good old time too. I don't know.
Light it up.
Yeah, I did. Oh, and the other thing is, I got on the phone with Lou, our friend at Microsoft,
Yeah.
to him about a few things, and it turns out that me on a Windows box with micro ROS and that kind of thing, wanting to talk to a Teensy or an Arduino type device over USB from Windows things, I'm the first one he's heard of asking for that, which surprised the hell out of me. But I mean, not so much. It surprised me a little bit. But he says they have well over 10,000 people using ROS on Windows, but most of them are ROS 1. Most of all his clients are the stuff he has to interact with on a daily basis are ROS 1 for their industrial stuff. The ROS 2 stuff, even though he likes it better, is just not as popular as the ROS 1 stuff is. You know, it's just, newer, all that kind of good stuff. So I'm not surprised by that. But I did talk to him. We had a nice chat about all kinds of things. He's already sent me a couple of ideas, and I've got some zany ideas of how to get past the fact that WSL2 cannot access a hardware port like a USB port or a USB port or a networking port directly. It has to go through the system interfaces. And not all those system interfaces work the way we would like them to work to get access to those hard direct ports that you need. And so I'm thinking a couple ideas, but I don't even want to go into them because they make my head hurt. And I'm trying to not make my head hurt when I do this. So there's that pretty much. So
Cool.
Things I've been doing, not really a whole bunch of robotics, but I'm wondering on these NFR boards, once I get done with the contest, if there might be something else interesting to do. The really weird thing I found was I was looking at the ports on all these ports here. I'm gonna put it back up one more time. All these things on all this board here, there's like 8 analog ports, and the rest of them are God only knows what. And because of the way they're built in on this DK board here, I can't use all these pins to do stuff unless I jump back over here underneath and start cutting traces. And they got pin places to cut specifically for, disabling that aspect of the board. I mean, they've been meant to do that because there's a lot of them right here and here and here and here and here and all that kind of stuff. But they've pre-allocated a bunch of pins for me already. So we'll see what happens.
Cool. So I was thinking,
I'm interested to hear.
Go ahead, Doug.
Sorry, I want to mention that I was interested to hear you got that heart rate sensor to work. I bought several of those, and maybe my source wasn't any good, but none of them worked when I got them in. Plugged them in, nothing happened.
Well, I'll tell you, there's something else I was playing with too. INA 169s, which basically is the current sensor, and it's one of these things that puts out an analog signal, and that goes up in voltage depending upon the current. It actually is kind of a real neat circuit with a comparator in there, and using a couple of resistance values in there to dictate the voltage level you get out. But I wasn't. Those things kind of suck. I can tell that I'm using current. I really can't tell how much because I thought it was working. It turns out I was just measuring noise. It turns out, and I'm like, that's screwed. So I've got about 20 of these, 25 different varieties of measurements of analog circuit little boards coming from China. They'll be here sometime next month. And there's 2 or 3 that do the analog out, and I've got several of them that use I2C to do this, and they send you a signal, and those are supposed to be way better because they've hopefully taken care of most of the noise on the breakout board, and you're just getting numbers out of the chip, that kind of stuff. But anyway, I'm going to play with some of those when they all come in too, and figure out which ones I like and which ones I don't, specifically for tracking this stuff on robots. Or anywhere where you want to measure the current and being able to calculate how much battery life you have, or at least have an idea. Maybe you won't get, I don't know how precise you can get with all that, but at least give you a general idea that, hey, I'm using half an amp what can I do? And I know how big my battery is. Maybe I make a guess of how much running time I can have before I need to shut down, something along those lines. I don't really know what I want to use it for other than information to display on some statistic somewhere at the moment. But that's kind of things I've been playing with.
Cool.
Yeah.
That's cool.
Having a good old time.
Hey, can I suggest that we next go to a guest? We have a new visitor tonight.
Oh, sure.
Uh,
Sure.
Yeah. So Swami, welcome. Good to see you. Hope you're getting something out of this and enjoying it as much as we normally do. Hope your audio is not quite working. You're unmuted, but
Maybe
see
double
muted.
mute, maybe.
Double mute, like the laptop mute or the headset mute. Or maybe
Bad connection. Mute.
maybe it's like the Dave Anderson mute where he just moves his lips and pretends like he's saying something.
Yeah.
No, he'd never do something like that.
No, he wouldn't do that.
Well, we do have
Oh,
two
man.
Swamis on. We do have two Swamis. One's muted, one's not.
It's funny because you can't win. You either got feedback from two microphones or no audio from two microphones. It's just not.
Still nothing.
Can you turn up your volume on your laptop? Try that. Speaker output.
Okay. Hey, Swami, maybe if you work with that, we'll just bounce right over maybe to Ray and then come back to you. Okay. So what do you got, Ray?
Well, I had just, I know Chris was talking about, video latencies, I think around, 50 milliseconds or so, which seemed, very fast. And I have this ESP Cam 32, this little board that's used in everything from home security systems to you name it. Let's see, this one, yeah, that one does have an SD card, so you can actually use it standalone if you can't get a good connection to it, and just look at the SD card later. Images on the SD card. Anyway, so the delay that I was finding if I used VLC to stream the images to, it was more like 2 seconds. So I was amazed. It's like, and I thought maybe the stream was being buffered or something. But as far as I can tell, it's not. So yeah, literally 2 seconds. Like, move my finger in and move it out, count 2 seconds, and it'll finally show up in the image.
What protocol was it using? Was it using RTSP or?
Yes. Yeah. So
What's the frame rate?
What's that?
Frame rate.
I think it was around 25 frames per second, which isn't bad.
You do get the 25 frame per second, just delayed.
But it's just delayed 2 seconds.
Yeah.
Where is that data?
Yeah, that's what I'd like to know.
somewhere.
Yeah, there's going to be buffering. I think what I found, anytime, so in the context of the Pi, right, where the camera gives you just raw H.264, anytime you go through another layer of like packaging that raw data into something like an RTSP stream or something else that's supposedly designed for this use case, you start adding delay because of buffering and whatnot and the packaging that needs to happen. And so everything I've been doing where I've been getting decent results is just that raw H.264 stream going straight into something that's able to decode that raw stream, nothing in the middle. It's just kind of a dirty hack. It's not really, there's not a lot of robustness there, but it cuts out, any layers in the middle. So that's how you get like 100 milliseconds or less.
Yeah. anyway, so I was kind of curious, dug it out
And what
Try
was
it
it? What is that camera putting out? Is it motion JPEG or H.264?
yeah, it's motion JPEG.
Hmm.
So
Okay, so then, okay, if it's motion JPEG, that ESP chip, I mean, I don't think it has any hardware acceleration. Well, maybe it does for compressing the image into JPEG, but if it doesn't, well, that's going to take some time too. But then you're saying you're getting 25 frames per second. All right, so that can't be it then. If you're getting the frame rate, then it's the buffering somewhere. Yeah. If
somewhere,
you're getting the
yeah.
frame rate, but
Probably on the
you're getting high
computer.
frame rate, but you're getting high delay, it's buffering somewhere.
Somewhere, yeah.
Because nowhere can hold this 2-second 25 per second frame in the
No,
air.
I mean,
A
couple
lot of
seconds,
people
that's
trying
not
to-
unusual. I mean, don't say that. I mean, 25 frames per second, 2 seconds, so that's 50 frames. In this case, 50 JPEG images. They're going to be what, 100 kilobytes each. So we're talking what, 5 megabytes. We're not really talking huge amounts of data here, right? So that's just either
Reasonable
on
number.
the source or destination side or both. You're going to get some buffering.
Yep. Anyway, so that's what I've been playing with. I got a few more motors in. These ones actually have access to it's like a worm and worm gear drive, and I didn't realize there were models that you could get that had access to the back of the motor. So it has a little 1/8-inch square slot that I can stick this 1/8-inch key into and basically make an encoder in the back of the motor. So, and those are for, excuse me, the linear actuators for the riding mower that I want to automate. So it's, to cut the grass. So they're, let's see, they look like this. I'm gonna tear it up if I drag it over there. I had showed it to you guys before, but anyway, got those in. That's about it.
Hey, Ray, how much is that ESP32 cam?
This one, it had a little, FTDI board with it. I think it was under $10. I got it off Banggood. That's the, basically how you program the part is with this adapter, and that's the, the little board sitting on a prototype board, or yeah, I guess you call that a prototype board, but it seems like they're on sale all the time in Banggood. You can usually get them for like that combo for under $10. And there's a couple different variations of it. Some of them have basically the FTDI chip built in, and they have a lot more pins. This one doesn't have very many pins on it at all. I don't know if you can see it, but it's got maybe a dozen pins on each side. $1.09. Oh my God. Is that right? There's no missing decimal point there.
That's what it shows as I do it. I mean, the internet's always right.
Oh wow, boy.
Free shipping though. Now, if Harold could get it in 2 days, I mean, forget about your frame rate delay. Just route it through Shenzhen. It'll come faster.
That's amazing.
Okay, anyhow. Ask Google.
Amazon has to watch out. If it's free shipping 2 days from China, Amazon is bust,
Right.
Well, I'm looking at this 1.091. Is that real?
Well, it's got to be real. I saw it on the internet. I mean, you might have to buy 50,000 of them. I don't know. So just look it up, man. Just look it up.
Very
Okay,
cheap.
it's always
And-
fun. Find a lower price. It's going to be out there somewhere.
Yeah. Instead of a Raspberry Pi and everything, you can
Now,
set these
you
up.
know what you have to watch out for with AliExpress? They always give you this range. Like in this case, it's $1.09 to $5.05
Yeah.
because they have different colors, right? Where by color, they really mean they sell 5 different things with 5 different prices, and they call it a different color. And so you got to watch out what it is you're actually, getting. And
Yeah.
Yeah.
Plus, there's which truck it fell off of too. That problem. So, yeah.
Anyway, so I was just kind of curious as to whether that would work for the, telepresence, demo, and not with my setup, it won't, because I don't have a router. I just have a hotspot, and so
but okay, so in your situation, you could use the thing that Carl pointed out the other day, this NG grok thing, because all you need is you need a Pi or something like that. I'm not, yeah, straight out of your ESP cam. I'm not sure how to do it, but you need some other middleman in your local network. But as long as you've got something else on your local network, I think you could make it work with either NG grok or with some other SSH tunneling kind of hack.
yeah.
Right? As long as you have an outgoing connection and some way of establishing a tunnel here. So NG grok would be a good use case for this.
Yeah,
Might be.
I'll get that.
Yep.
Maybe it's possible. Yeah, I have
I was thinking about what Chris had showed the other day, and that was strictly video, not audio, correct?
this little
The
camera,
thing-
or what Chris was showing.
What Chris was showing a week
Yeah,
or so
just
ago.
video. I
with
don't
his
even have a microphone hooked up to my Pi. I never have played with audio on the Pi, to be honest. So
something we have to consider for our telepresence project.
yeah.
Got to have audio.
When
At
I
least if
was
you're going to be at Lake Murray.
when I was trying to do this meeting on Pi, I had to buy one of these little. The easy way was to buy one of these little modules, and I think they were under $10. I don't know what, $5 or so. And you just plug it into one of the USB ports, and it gives you audio and a microphone. That's the way I would go if I were you. It's literally just plug it in. I think I had to look up something on the web and make one. You have to find the name of this thing.
Yeah.
Otherwise, it becomes a device, and you have to change your default to this device. But it's very simple to do.
But we also talked about separating the video conferencing stuff, right, from robot control, and just using a phone or a tablet and running Zoom on it or Google Meet, and that's your telepresence part. And then some other camera in the Pi is more for the autonomy and maybe interactive real-time control part.
Yep.
You got the engineering camera, and then you got the sightseeing camera. Oh, wait, that's the Perseverance robot. I keep getting mixed up. Okay. Yeah. You got that. Well, cool.
Anyway, playing around with it to see if I could get it to work, but doesn't look like I'm going to be able to.
Next Tuesday. You got another week, man. Make it happen. You can do it.
Okay.
Cool. All right. So let's swing back around. So Swami, any luck now with earbuds? Oh, yeah.
Yeah, can you hear me? I'm calling from my phone, actually. So
It works. Yeah.
all right. So a little bit
Welcome.
about me. I'm from Texas, Plano. I live in Plano. Are you guys all from Texas or from Dallas?
Most of us.
Okay.
Yeah, I mean, we're based in Dallas, but you've got someone here from Connecticut and someone from New Zealand. We had someone earlier from Chicago, and we often get someone from Portland, and sometimes we get someone from LA.
And
Jane,
Seattle.
Jane from California.
Yeah, California And I think we had someone from Kansas at one point too. So, oh, in Canada, we had Pat on. Pat was from Ontario, Canada earlier.
Okay, that's great. All over the world.
We have a broad view of
Yeah,
Texas, you see.
Okay. Yeah, I'm from Texas. I've been here for the past 20 years, I guess. More than 22 years now. I got interested in robotics a few years back. I started building something. The first thing I built was, it's a bit bulky. This is actually a 6 degree of freedom robot I was building. This is just the base of it. So this is actually heavy. It's capable of delivering about 250 Newton meter torque. So this should be the base. And I have the other stuff. I have not hooked it up. So it's actually, this is just the first joint of the robot. This basically has a motor, a BLDC motor, and it's got a harmonic drive gearbox. So it's basically, harmonic drive is really very compact gearbox. Actually, I have a sample that I can just show you what it looks like.
That's some big bucks getting into harmonic drives and everything.
Yeah, whoa.
Yeah, so actually, I'm still building it. It's kind of, this is already assembled, so the harmonic drive is inside here. This is a smaller giant, but yeah, so once I am able to build it fully, I kind of will be able to show you that. This motor is interesting. It's actually, it's got a encoder that's actually 4K divisions. It's not an absolute, it's an incremental encoder. So I don't have an encoder for the giant, so I was trying to do something just by having some kind of an LED and a diode to detect the position, initial position, and then I'll just use the motor encoder to actually figure out the actual position of the giant. So hopefully that should work. I'll have to figure that out. To drive the motor, I actually recently bought this driver. It's a VESC driver. It's actually VLSC. It's an open source driver. Usually, if you Google search VESC, this actually is designed by a person called Benjamin. He has everything online, and actually you can download the drivers, everything. I'm actually using the CAN bus here. It's got a CAN bus. And actually I used a TIVA C-Series, TIVA board from Texas Instruments. It's basically, it's got a nice CAN bus, so I could actually connect this to this driver. And the good thing about this driver is actually it takes velocity, position command, and all that stuff, and I can just directly provide it whatever I want. And this board, I was able to connect to my Intel processor. I have another small processor board. This is actually Intel processor. This is actually AE. It's a company called AEO, and I'll send you the details once I don't have it off my head. So I just use the UART port to connect to the TIVA board, and then from here to CAN bus, I just drove it. The idea is eventually I'm going to use this to serially control about 6 boards, which will be connected serially to this. 6 of these boards will be connected serially to UART ports. I did a small modification to this. UART is a single line, so I added a small differential line to it to power noise immunity. So basically, just I can do. Actually, it's currently running at about 10 megahertz, I guess. So that's the fastest you can go to. So yeah, you guys talked a lot of interesting things. I just noted a lot of things. It's really interesting. You guys are into it as well, and I really got excited after hearing all of you, and that's why I kind of jumped in. So I can share more details probably next time on the things I did. But my goal is to actually start running this and connect the next. I have the other joints connected. Driving this, that's actually a 75 volts supply. And this one takes about 60 volts. I'm probably initially just going to drive with 60 volts and get the torque that I need. It's probably going to give, my estimate is the arm is going to be able to lift a payload of about between 7 to 10 kilos or about 20 pounds. So it's a bit heavy. I started with the heavy stuff. I didn't want to actually, but I wanted to build something lighter, which is what I'm going to do after this. I'm also building a mobile robot. I have what I did. I don't have it here. I have it in my garage. I just ripped off a hoverboard and started using that as a base. And so I removed all the stuff and just going to connect aluminum base to that hoverboard. I have two hoverboards, so I actually have a four-wheel drive. So it's a four-wheel vehicle. Directly use the hoverboard and see. My initial experiment was not very great. The hoverboard flipped a lot. Just because I gave a torque command, I'd probably like to give a velocity command and see how it does better. I need to do more experiments to make it work. So yeah, I'll let you guys know how it goes, and glad to be part of this group. You guys have done a lot of interesting things. I would like to hear more about it as well in the next few meetings.
Hey, very cool. And
You did-
by the way, so if you're gonna, it sounds like these hoverboard based thing, your mobile robot is likely going to be okay for outdoor use, right? Moving around outside.
It can be used indoors as well, so because it's pretty smooth. I was riding on the hoverboard inside my house. It's actually pretty cool. It should be able to ride. Actually, it's more for indoors because it doesn't have the height. It's pretty small. It's 8-inch wheel. So it might. I ran it. I tried to run it in the grass in the backyard. It got stuck several times. I'm not sure how I'm going to run it. Probably need a bigger hoverboard or something. Maybe something if I can rip up a Segway or something that might work well. But
okay.
I looked at AliExpress. You get a lot of up to 12-inch, 15-inch wheel drive, drive. So you actually they already have the embedded motor in that. You don't have to fix the motor. It just comes up with an axle. And all you need is a board like this to drive it. And it just runs pretty well. So, and a can drive or something. So you don't need to hook up a motor to a wheel and all that. I kind of find that goes pretty well. And AliExpress has got, those guys have like from wheels from like 5-inch to 12-inch to 20-inch, and you can literally drive any big size.
That's huge. That's much larger than most of our robots, I think. But I mentioned the outdoor thing because we have an event coming up in August, third week in August probably, for a little. Good night, Chris. A little outdoor competition, and
okay.
if you wanted some excuse to cobble together something that, I mean, not through thick grass, but something that could navigate around an outdoor course, we got a challenge for you. Yeah.
Oh, absolutely. I love that. Yes, I have been drinking with. I got a stereo camera recently from Stereo Labs. I wanted to use it for some other purpose. I also have a camera from Intel. This is basically it's a point cloud camera. It uses it can actually detect. It creates a space. The range is about 20 meters. I haven't tested it out fully. I wanted to do some terrain measurements and stuff. So this is pretty good from RealSense camera. It's called RealSense from Intel. They give all the software, everything, and it runs pretty well on almost everything. I got an NVIDIA board recently. It's the Jetson board, TX, not even the TX. TX2 I already have, and it works almost with all the boards. So you get this one, and also I have one more thing. I have one more thing from TI. I'm not using that. They don't support it anymore. But this one might work pretty well for point cloud stuff. So
yeah.
And Intel supports a whole lot of libraries. Yes.
The RealSense camera, is it the 415 or the 435 or?
You mean the number of frames per second?
No, the model.
Oh, the model. This is the I don't remember actually. This is one of the older models, D35. I don't remember the model names. I can send you that.
Oh yeah. Okay. Huh.
they have come up with newer ones. They also have come up with lidar, single layer lidar, like one, what do you call it? Just a single point lidar. So you probably can mount it on the motor or anything and start using that. And I haven't thought about that yet, but I would probably use actual lidar in some of the next projects I'm thinking about.
Very cool. Yeah, well, nice to meet you. Welcome. Look forward to seeing you again. And we have we also have monthly meetings on the second Saturday, and coming up this Saturday, the 13th. I don't know if Kareem is still here, but Kareem runs a team of high schoolers, and they're going to give an update on their project, which is pretty cool.
Cool.
And then I think
do you guys meet? You also meet somewhere before the COVID? You guys used to meet somewhere? Or?
Yeah, we normally meet, or we have normally met recently in the Dallas Makerspace, but we haven't met there since a year ago now, I guess, since March. But we're looking forward to get past COVID, and that's part of our challenge is to figure out now that we have a handful of folk that aren't in Dallas, and there's some folk that are even in Dallas, but like the interaction we get on the meetup online here. So we're trying to figure out a nice way to get the best of both worlds, in person and remote. So we have this project the kind of a club project, ad-hoc thing that's going on where we're trying to come up with a kind of define a kind of a platform for a telepresence robot. I mean, it's the obvious thing to do, but to do it in a way where anybody could build to the standard, and then you could have like some kind of web interface where if somebody logged in, then they could sign up to use somebody else's robot, and then we could have virtual participants. But we got to build it ourselves. So.
Oh, cool. Nice.
So who knows where that'll go? But there's several of us picking away at that one.
I'm making good progress.
And the competition you were talking about, where like I think I saw it on your website with like sometime in August. Is that the one you're talking about?
Yeah,
okay.
It's a plan for probably if it sticks, I think the 21st of August. And I'll put a link. I'll put a link to the kind of baseline rule set. They're going to change a little bit, but it'll be looking something like that. Just kind of a navigation task.
Okay. And you guys have formed a team, or people are forming teams, and how does it work?
Mostly individuals.
Mostly.
And there's a couple of ringers who just knock it out of the park every time, and then there's some of us who've never tried it before, like me. So.
Okay.
So we'll see if we can get our robot to turn on and move a little bit. Maybe find the cone. I don't know.
Okay.
Get a whole range. Oh, cool. All right. Let's see. I think that takes us down. There's two more persons who've been very patiently waiting. So we got John and Kareem. Do you guys have an update for this week?
In my case, no. Unfortunately, I got sidetracked doing other things, so I haven't got around to dig out the Raspberry to the degree I wanted to, or put that outdoor robot base together that I had shown you last week. But hopefully, maybe this week now, with all the rain that we're going to have and be indoors, I'll do stuff indoors.
Some good quality robot time coming up. Excellent.
I got nothing.
Nothing. Okay. Well, you got a
I think
team
my boys
to manage.
my guys are going to say enough on Saturday.
Now that's at 1 o'clock, right?
1 o'clock Dallas time.
Okay.
So UTC, what is that? I don't know what time it is, UTC. I don't know. It's in the meetup. You have to do your own math. That's beyond my pay grade right now. 1 p.m. U.S. Central. Yep. And then, by the way, so we have Iron Rain, Kareem's team this Saturday. Penciled in for April, we have Jesse Brockman. That's our Spark Fun guy. who's going to talk about his outdoor project, I think. And then the following, at risk of this falling apart. So Harold, you brought up this one European Space Agency rover project a few weeks ago. Well, it turns out that Murray got in contact with one of the guys who did that.
Oh, cool.
We've been trading mails, so keep your fingers crossed. But there's a chance that in our May meeting, we're going to get Max and Myro, I forget his other name, but two guys from the European Space Agency to show their project.
Yay.
Fantastic.
Yeah.
Go, Murray.
So fingers crossed, but Harold, that's between him and Lou. You keep finding these great presenters, so that's awesome.
Now, his name was Maximilian Earhart, I think.
Yes. Yeah, but he and there's another guy I think
That was
they
on
come
the
to
team
there.
with him.
Yeah.
Yeah, it was the other guy that was on the team with him. Yeah.
Yeah. It's Miro.
Mhm.
Miro Volmi. So Max and Miro and Max.
Is that going to be a Saturday or a Tuesday?
It'll be a Saturday, well, Sunday for you, but
Well, I'll probably get whatever that is. Make sure I'm there. I'll get up early or whatever because I don't want to miss that one for sure.
no, yeah, no problem. Well, I invited them to this Saturday as well. So Kareem, don't spill the beans, but I'm crossing my fingers that they might show up, and so you might have ESA people that can give feedback to your team. So with any luck, I'm hoping.
That'd be cool.
Wouldn't that be something?
That would be cool.
So we'll see.
Yeah. How much did Perseverance cost? Was that a $1 billion robot?
Something like that.
Well, the ExoMars ones is considerably simpler. That's a different robot, of course. That's the European model. I can't remember what the budget was. It was considerably less than the NASA one.
I think the NASA open source was like $2,500, and this ESA one was maybe $1,200. But I want to say something like that to build. And they were recommending to, if you don't just, rather than have a shop print everything for you, just go and buy a 3D printer and some filament, and it'd be cheaper than having someone else print it for you.
Well, who would have thought? I mean, I know because we're all geeks here, and watching that thing that's going on the Perseverance in Mars. Who would have thought it would be hard to fly something on Mars? It would just be hard, like getting a thing light enough, powerful enough to generate, and fast enough to generate enough lift just to get off the ground.
Yeah,
Mars. We've been flying for quite some time. You'd figure we would know how to deal with air, but I know there's not much of it there and other things like that. I just find that to be a problem I did not expect we would have. Right?
Right?
Did it take off yet? They haven't tried that yet, have they?
No, it'll be a while.
Yeah.
Yeah.
I'm actually amazed that they think they're going to pull it off. The atmosphere is so light there.
Yeah.
But they've modeled the propeller on that thing. I think that they have a pretty good idea of what they need to get off the ground. I think it's
they've even tested it in similar atmosphere, right?
In a giant vacuum chamber.
Pump to test chamber and such, but still, it's still pretty amazing to me.
I think the thing is, if it messes up, there's really no recovery. It's not like you can just go over across the lawn and pick it up.
Flip it up, yeah. Dust it off a little.
Turn it over.
They have the opposite. They're trying to get this done in not Saturn. What is the one closer? Venus. They're trying to get this done in Venus too. I saw some things. It must have been a year ago, where they have kind of the opposite problem. Well, besides the Venus is
incredibly hot.
It's corrosive and extremely hot.
Yeah.
Their atmosphere is so thick that they need to turn their propellers slower, way slower, and they're having to do an over-under counter-rotating propeller to get slow enough speed, but still generate enough lift for them to get off the ground on that thing. They got some of the opposite problems going on there. It's kind of interesting that I run across those things. And I don't know where that is. It's been, like I said, it's been a year since I've heard anything about it. So it may have just died a horrible death. Who knows?
All right, guys. Well, cool. Well,
Bye.
I hope you all have a good evening. Look forward to see you this Saturday, and keep building. Talk to you later.
You guys.
All right.
Bye-bye.
Good seeing you guys. Bye.